Yeah.
Oh yeah, so that's Jaap, in case you weren't aware. My name is Justin Grote, and we are today going to be talking about Pester and Pester testing, and we're going to start with some of the basics and then go into a lot of the details and some of the fun tips and tricks, and then we got some fun stuff to do towards the mid and the end. So we got a lot to cover, so we'll get right to it.
So we'd first like to thank the sponsors. Wouldn't be here otherwise, so here they are, there they are. They give away goodies, so go say hi.
Yep, and a special thanks to my company, Ally Digital, for sponsoring my travel. So if you're in the market for a good MSP, come check us out sometime.
Cool, yeah, I'm Jaap. I do a bit with PowerShell. See some familiar faces, see some new people. So yeah, Justin.
Justin Grote, I'm a Microsoft MVP. And he asked me if I wanted to change that description. I'm like, no, why? That's perfect. That adds it up just right. Spock is my dog, by the way, for those of you who don't know.
So yeah, the agenda for today. We're going to go over the basics of Pester, talk about why we should be using Pester, the specifics about it, and because it's a 3.5-hour session, 3 hours of actual content, we are also expecting a bit of interaction, because otherwise it will actually turn into the Jaap and Justin show, and that's not the idea of a workshop. So at any point, if you have any questions, you can raise your hand, but my experience is just shout at us, then you get direct interaction, and that's what I would recommend. Next.
Yeah, so
yeah. Oh, is this me? Yeah.
well, I can just get off the stage at this point.
Cool. So why do we actually want to do any testing? And this is something that I struggled with when I first heard of testing in general, because I knew it was a thing for software developers, but for me it just seemed like extra work. But it turns out it is actually extra work. But it can save you. It can save you a lot of time as well. And there's been cases where I had to. There was a repository where I actually included unit test. I made a change to my code, and then the test failed, and I got rid of the test, committed my code, and then a week later I had 5 angry customers because the test was actually properly identifying that I did make an oopsie in my code. So that is what it boils down to. What we are trying to do is, whenever we are writing code, that it's reliable and maintainable. And the maintainability part comes from the fact that you have a certain certainty that whenever you commit code, that there is validation aside from you being a genius or me being a genius. Because in the end, we all have to accept that the only genius is Justin.
I have audio evidence for that. So. Thanks, Andrew.
Yeah, so try to get rid of bugs and issues in production and make it easier for yourself to commit to projects that you might not have worked with for a long time, because the longer ago it is that you worked on something, the harder it is to get back to a point where you are up to speed and confident that you know what you're changing. In addition to that, it can also help your colleagues or other collaborators to get more confidence in committing code. So the type of tests we have, there's a lot of tests available. The ones that you are most likely to write are unit tests. So whenever you're writing unit tests, you're trying to get the smallest portion of your code. So unit tests. Integration tests is when it's more on an end-to-end level, when you want to make sure that an end result is reached. Acceptance testing. Infrastructure tests is something that Pester is very well suited for, because PowerShell is a language that is specifically for administrators, often used by administrators. And performance and security tests are something that I've occasionally seen, but not a whole lot.
I think too, like with tests, like one thing about you see all these names up here, and this can be really intimidating if you've never seen these. Like, well, what is a unit test? What is an acceptance test? Just think of these as loose definitions as an easy way to categorize. So when I say like I'm writing an acceptance test, it's just sort of like so people generally know like what the scope is going to be of it. But these aren't like hard and fast definitions. Like there's not a keyword to do a acceptance test versus an integration test. These are just sort of more generals, but a test is a test is a test. You're trying to set up an environment. Do something where you can get the environment to a certain state and then verify that it does what it's supposed to do, and then assert that the result is correct. So you may hear this term AAA or arrange, act, assert. And the idea is like a really good test typically is the first part of the test is setting up the test, getting the whole environment to where it needs to do the test. And then there's actually doing the piece of the thing that you're trying to test, whatever that is at whatever scope. And then there is verifying that whatever you did actually worked, and that's the assert part. So if you hear those words, some people like to put those under each heading and like put comments. Here's my arrange section, here's my act, here's your assert. I mean, you could do that. I think that's kind of extraneous. But if you just kind of general follow that flow, it doesn't work in every case, but it's a really good kind of like standard way to write tests, regardless of what kind of test it is. So yeah, so Pester is PowerShell's approach to unit tests. And when I say PowerShell's approach to unit tests, I mean some guy one day was just like, hey, I'm writing scripts and these are kind of annoying. It really would be nice if I had a way to write this, if I had a way to like test this stuff. And thankfully, since I work for Microsoft primarily in testing, I'm going to go ahead and write it. So that guy is Jaap. He is a Czech guy who we all love and we all know, and I love to make fun of him and do impersonations. But he's one of the sweetest, most nicest people you've ever met. And as a result, like he's able to just develop these modules, and he has like such a great focus, and all the people who've contributed to Pester over the years have really helped it to become what it is. And in a remarkable thing about Pester too is Pester is one of the only third-party PowerShell modules. Not even though Jaap was part of Microsoft, he wasn't in and out for that. But when it shipped in Windows, it wasn't technically a module written by Microsoft. So the version of Pester that is now ancient, but the one that ships in Windows, is one of the only PowerShell modules that's ever been like a community module that shipped in Windows with its lifetime. Like it was really amazing achievement at the time. Since then, there's been a lot of improvements that we're going to talk about and such, but in short, this is just the current like de facto way to do testing in VS Code. There's nothing stopping you from writing your own testing framework. There's nothing particularly magical about Pester. It's just like using like VS Code versus Notepad versus Vim versus whatever. It's one way of doing testing, but that we've all agreed like, hey, this is actually pretty good, and there's a really good community and ecosystem around it. So it's more or less the de facto way of doing testing. And so that's mostly what we're going to talk about today.
And I think in addition to that, Pester also doesn't do anything that you couldn't do yourself in PowerShell as well. And yeah, to Jacob's credit, once again, well, yeah, that should be super nice. Yeah, he actually did sessions where he showed, okay, what if you don't want to use Pester and you just write your own test? How much work would that be to get the same kind of functionality? So it is all something that you can do yourself as well. Mm-hmm. But what Pester allows you to do is do it in an easier way, and it's already there. So
yeah, they do all the ugly, complicated stuff so that they can present you sort of a simpler way of doing it and seeing the output. And Pester, again, Pester is open source. You can go out to the GitHub, you can look at it, and you can see how it works. And it is still, originally it was 100% PowerShell. Now it's about 80% PowerShell, just because some of the data types, and just, it's the thing we all learn as we do this, is like there's certain parts like, hey, maybe it would be good to write this part in like C#, so because we want this data model to be really like solid and structured and type safe and be able to do all that stuff that we want for that. But that's primarily just for some of the data model, that stuff that exists in it. All the kind of core guts and the operations of Pester is still 100% PowerShell. So you can go in there and you can look at it. Some of it's going to look pretty Byzantine because it's PowerShell doing things that has to make sure it doesn't get in the way of whatever you could possibly write. So all the variables have like 10 underscores behind them and stuff. Hopefully you would never use that kind of a thing. But for the most part, there's some pretty creative tricks used in there. There's a lot of really neat stuff that still makes it so that it works to be so down level compatible and still operate. But yeah, as Jaap?
Yeah.
Okay. As Jaap said, there's nothing that Pester does that you couldn't do yourself. It's just it's a toolkit that helps to do tests. But and we've all kind of embraced it as the de facto, as I've said before. And so everything you see is just wrapping around that. But there's nothing here that you can't just, in one other way, if there's something that doesn't work for this for you, you could be the next Jaap Yares and write your own. But we're going to show Pester today.
I think we already covered this one. Well,
Oops.
we didn't highlight that you are here to help people. So. Yeah, that's. I don't know how many years back this is. It's already a while.
3 or 4, yeah.
Yeah, 4 years. So Pester, there was a big shift in Pester going from Pester 4 to Pester 5. I guess somewhat similar in the sense with PowerShell 5 to PowerShell 6. The main changes are that there were a lot of commands that were deprecated, that were already advised not to use anymore within Pester, and starting from Pester 5, it was no longer possible to use them. And the one that hit me, because I don't like doing things very strictly, the scoping became very strictly enforced. And what that meant was whenever I assigned some variables because I wanted to test it, and I did it a lazy way and I didn't put them in the right place, with Pester 5 that stopped working. So yeah, that forced me to code better. I didn't like that.
Yeah, so Pester 5, one of the biggest things that it introduces, I mean, if you're not familiar, if you've just been writing tests, is it sort of very strictly separates the discovery of test phase versus the actual execution of those tests. And the reason that was really done is so that you could be a little more lenient and a little more creative in the ways that you define tests, being able to define dynamic tests, being able to define tests based on a data set, so you didn't have to write the same thing manually over and over and over again. Unfortunately, what that changes is that if you're used to writing Pester 4, then there's things you can get away with in Pester 4 that you can't get away with in Pester 5. And so it's not just a straight your tests. Sometimes your tests will work as is, but a lot of times there's like little things you have to go through and convert. So it's not something we'll cover too much in this, but it's just something you just need to be aware. Most of the time, like if it doesn't work, if you then put it in a before each or before all, it will suddenly start working. Like that's pretty much like the #1 way to fix Pester 4 tests and do Pester 5 is like a general rule. But the big thing here being is that just be aware that this is sort of like the Python 2 to Python 3 kind of like somewhat fiasco, and just it's a big breaking change. It was very good that it happened, but at the time it does make it very difficult, especially if you have a very large test base, to get those converted. And so thankfully, like I can say all the VS Code tests are Pester 5, thankfully. Andy and I worked really hard on that to get that going. But you still may come across environments where, especially if you're inheriting an old code base, where the tests are written in Pester 4. And so you'll want to plan that if you install Pester 5 and run them with Pester 5 and they break, just be aware of that. And on the Pester site, there's lots of information about what changed and the typical ways you fix those things. And I think at one point, actually, I think Jaap, didn't he write like sort of like a somewhat, I think there's like a somewhat of an auto fix. This probably doesn't work anymore, but he had a script that would actually like find those places that were wrong and automatically update your code to the Pester 5 operation. But I don't think it's as popular. I don't even remember if it's in the docs anymore. I don't know if you remember it or not.
Yeah, I don't remember that. And otherwise, the workaround can also be to just load an older version of Pester.
Yeah, you can still also run them separately. The one thing I will say is that the VS Code extension that I wrote for Pester only works with Pester 5. And that has more to do with some architecture stuff than the formats. So like if you use Pester 4 and you still have Pester 4 tests, you can't use my extension to run them. So.
The one thing that's not on the slide, but that's important to note, whenever you use Pester that's installed with Windows, that's going to be Pester version 3 point something.
3, I think.
Yeah, so definitely upgrade that. If not to 5, at least to 4.
Happy dogs times. So we were just figured we would hop through with just a few demos of a couple different really simple, basic kind of Pester stuff. So I just have here, this is like, whenever I'm like just testing out my extension, is that not mirroring? It should be mirroring.
Windows P.
Well, it was there before, thank you very much. So oops, we're getting a cart before a horse here. So this is one of my favorite tests to do, like whenever I'm just like starting something out just to make sure all my Pester stuff works, is you have describe at the top. You always have to have a describe. The describe kind of lays out your test suite, as you will. It's just simply like, it's just a simple way of categorizing tests. You can nest multiple describes, and so when you go to do your output of Pester, you can see that. It's just a method of organization, but you can't just have an it statement out there by itself. Like, you have to have it in some kind of describe block. But then the very next thing is simply it. And what you might notice here is, like, these are not normal PowerShell commands. It's not start describe, it's not invoke it. But all of these are actual legitimate PowerShell commands when run within the context of Pester. So this is what's known as a DSL, or a domain-specific language. And so the idea here being is that we wanted a very kind of simple, and when this was designed, it was done as like, hey, what if we had to write a really simple and descriptive way to write tests so that we don't have to have, we do love our, our verb-noun syntax with PowerShell, but when you're writing tests over and over again, it can kind of get in the way of the clarity of what you're trying to do. Because one of the really nice things about tests is, ideally, sometimes you can show this to like somebody in the business, somebody who doesn't maybe understand PowerShell, but you could work with them if you're doing like a test-driven development or behavior-driven development approach, which the syntax of Pester is based on some of the behavior-driven development concepts, which we'll talk a little bit about. But in short, the idea being is that, wouldn't it be great if you could go to your manager, it's like, hey, we need a new PowerShell module for managing this thing or automating something in Azure that we built. Or our product has an API and we want to have a PowerShell module to give to people. Okay, well, what are the scenarios that we want to make sure? It's like, hey, you're contracting with me, or as your employee, like, I've got X amount of time. What do we want to implement? Well, we want to make sure that if they go to this website, it returns this result. If they go to this website with this, it returns this error. If they run this command, they should get this certain result. And you can write those in such a way here so that anybody in the business can, they may not know PowerShell, they may not be able to read the internals, but at least from the describe and the it, or watching like the test output, they can kind of get an idea of like what we're testing. So that they can ask good questions. They can say, well, why don't we test this? Or why don't we test that? Or our help desk constantly gets calls about this thing being broken. Could we add a test for that? And then they can kind of describe in the language what it looks like, and then you can kind of define it up here and be like, does that look like what you're trying to solve? Yes. And then you can go in the back end, do what you need, and then you'll always have a test to test for that thing, whatever you're testing. So this, is typically when it works. Let me take that back out of here real quick.
Okay. Can I do an extra credit question for the audience?
Sounds good.
So, as Justin mentioned, it's a domain-specific language, a DSL. Are there any other in PowerShell that you are aware of? DSC. Very good. Any others?
Invoke build uses a DSC. If you don't know what invoke build is, a build tool, and one of the main things it does is task, and so the word task. And all of these they are just basically PowerShell commands in that context. They're just written in such a way that they don't require the verb-noun syntax. It doesn't like throw any errors by having them. So. Yes, yeah, Saki is another build tool, very similar to invoke build, like parallel. And so yeah, so they're very popular in areas where you're doing any kind of like description or anything that's kind of declarative, where you're not actually working your way through an iterative process. I mean, you still are, but you're not writing it like a script where it's like an imperative, like do this, then do this, then do this. When you're looking to like nest things and describe things with a model, using keywords like these kind of makes it much easier to read. If you have somebody in business, it doesn't have to say invoke describe, should dash it, or whatever. It's much easier to read. Describe this, it does this. And we will just real quick down here, invoke Pester is the big magic command that does everything. And when we do an invoke Pester, what it does is it'll search here. You'll see I have this in a test.ps1 file, which is right here. And when we do that invocation, it goes through and you'll see it'll run the tests, and then it runs everything that's in there, and we are good to go. So like anytime you want to run a test, that's the easiest way to do that. You can run it from any command line and get a summary if your tests work or not. And then there's a much more complex syntax, but there's also the output. And you can make this as detailed as you want. So if you do detailed, you'll notice this time it found the individual test. And you see here, there's that describe test. It works. And again, you can take this test output, show that to somebody, and this is just sort of a contrived example, but if I hop over here to, like, for instance, module fast, you guys don't know anything about how module fast works, but you can get an idea that here for my get module fast plan under parameter binding, hey, when I do these parameter binding tests, like, does it get that module with the correct name? Does it get it with the correct version? And you can go to each of these tests and kind of see the detail for how that test works. But again, if you've never really worked with this module before, you at least have an idea of like, what am I testing to make sure it works? Hey, if this shorthand way of fetching a module in ModuleFast works, you know, these are all the things that I'm testing for. And you can say, hey, you forgot this scenario. I'm like, okay, great. Let me add that to the test so I don't miss that. So does that make sense? Does that make sense how like you can structure your tests? And like, you don't have to make them like descriptive in this way. You can write the descriptions however you want. If you want to use a shorthand, if you don't like these long things. It really just comes down to like anything else, any kind of code conventions, anything about formatting. It just comes down to your development culture, the people who you're working with, whether that's an open source project and your contributors, if it's in your company, it's whatever your code standards are. It really just, there's no right or wrong answers. I mean, you want to use emojis, you can. Like we have plenty of examples that show that too. But it's just, it really, don't let people like get really rigid on you, like, oh, you must define tests this way. It's what works for you. And because ultimately that's what all of this is like, whatever works for you is going to be what's going to work best for your company, what works for everybody who's working on that project to agree on the best way to get these things done and make sure that you're testing what you need to test for good code. Yeah?
What are we looking at here? Is this part of the VS Code extension?
So this is, I'm kind of cart before horse. So this is one of my modules. I wrote this fancy, crazy, borderline psychotic module called ModuleFast. I'll bring up the site here real quick. It'll explain it a bit better. This is
not ModuleFast, the testing stuff inside.
Oh, yeah, I'm sorry. So if you go to extensions here, and so this environment is a very basic VS Code environment. It has only just a few extensions installed here, and one of which here is the Pester tests extension. Yeah. So that has all that. This is a test repo out there. It's written by some dude who clearly doesn't know what he's doing because all these links are broken.
Maybe should have some tests for that.
Touche. I should file an issue, and maybe whoever works on this would fix that. But yeah, so we'll talk about this a little bit later. I mean, again, we have a lot of time here, and so later we'll talk more about what this extension is and what it does and how it works. So going back to just kind of the basic example here. So when you have a test, ultimately what you want to test for is, you have ways of testing things. And so if you've ever worked with, how many people have ever worked with like a testing framework outside of PowerShell? Like, have you ever done like C# like XUnit, or if you're in like JavaScript, there's all kinds of stuff like Mocha and Jest and VTest and everything. And again, those are all great examples to see like lots of other frameworks have like 7 different testing frameworks. And that's simply because some people, what works for one team doesn't work for another team. Some want it to be more simple. Some want it to be like more behavior driven. And they want a syntax that looks more behavior driven. Some of them want it to be very test driven. They want everything to be assert this is this, assert that is that. Whereas others, they want it to read like business stuff, where they can say, this should be that, or this should be this. So that even like people who are not technically on the project, they could say a sentence like that. You could write the test so it reads like that for them, and they're like, okay, great, that's what we want to test, so that everybody can agree and get ownership. So that idea of writing tests where you say, this should be that, or this should not be that, that falls into the idea of behavior-driven development, in that we're testing based on the behavior of what somebody's doing, how somebody interacts with our program. And if you want to get into like all kinds of agile silliness, and get all kinds of things of like user stories and all that kind of stuff. But in the short, the core here is like kind of speaking in plain language. What do we want to enable? Like, what is the person, so-and-so as a person, what do they want to do in the program? And so we can write our tests in that way. And you can either choose to write the test before you write the code, so that if it fails, it'll go through. And Jaap will talk a little bit more about like some of those strategies and styles. But in short, I'm just going to show here, because it's that behavior, it was designed for that sort of behavior driven, all the commands work on that like should. So the most common thing you'll have is in this script block, it basically just has to resolve to something. If it doesn't, if it just resolve and the script runs, then the test is considered passing, as you see down there. If any kind of error happens in here, then the test will be considered to be failing. So at a very basic level, that can be your test. Like, you don't have to learn should, you don't have to learn any of those special Pester keywords. You can just simply write tests that either they work or they throw an error. And like at the very basic level, that's what you can do. The problem with that being is that there's lots of ways that you can end up with inaccurate tests. Like, you can have a test that throws, but has nothing to, the reason it's throwing has nothing to do with what's broken there. So what we usually want to do is we want to do something where we're doing that arrange, act, assert thing that we talked about before. So first of all, we want to have something like test equals true. This is a simple thing, Whereas this would be setting up, me running my command that goes and this command should be able to fetch a temp file from the directory that has a particular name. And so then we would just do this. And when you get there, should be able to just type should, and there should be IntelliSense on all this. So should is a special command that's built into Pester, and it's all documented. That is just a general tool that does this same kind of comparisons for like whether something is good or not, in the same way of just how we did like either the script completes or it throws, but allows you to put a lot more constraints on it. And just like the where object command, like how where object, you can do the script block thing, and that's typically what you do, but it also has kind of a DSL kind of syntax where you can just do like dash like or dash not or dash C like, that kind of shorthands that process. That's kind of like what the should command is. The should command takes all these kinds of assertions that you could normally do any other way in PowerShell, but encapsulate them into one command to make them really easy to utilize. So when you do the dash here, you end up with all these different ways that are pretty easy to understand what they do. Like, be greater than. I don't think anybody really needs a manual to kind of figure out what that's going to do. It's going to compare whatever this is, and is it greater than the other thing, whatever the language of that type greater than means. It can just should be true. Very simple test. So if we do that one, and we do, I'm going to continue to show it down here in the terminal. Ignore all my magic over here. Oh, I left my debugger on. This is a different thing. So if we run that, go away. Yeah, I still have my oops in there, yeah. Well, this is something different. Again, you know what? This is what I'm going to do. I'm going to go to my extensions. I'm going to disable the Pester tests so we don't see any of that stuff right now. Oh, by the way, did you see that restart extensions button? That is brand new as of literally the most recent version of VS Code. You can now restart extensions without reloading all of VS Code. Really cool. Doesn't always work, but it's pretty cool. Because as you can see, like, again, my extension has not, there's a piece you have to add to extensions now to work for that. I have not added it because it's brand new, so this is still showing up. So I'm actually going to do a full reload here real quick. And yes, Jaap, I'll let you speak here in a minute. I'm just on a tangent. So there you go, and you got sort of, yeah, I was in my debug thing. So notice, also I forgot to mention is that this gets nice and colored too at the command line. There's ways to customize these outputs, which we'll talk about later. But at this moment, you can see this test works because $test should dash be true. If I do dash be false, then can anybody take a wild guess what the result should be? Anyone? Don't everybody answer at once. I know it's hard. Really think about it. So if I invoke Pester on this, so this time I failed, but notice here I didn't just get, exception occurred and wherever. The nice thing about the should command is it goes through and gives you like a much more detailed information. So we were expecting false because it should be false, but we got true. So the really nice thing about the should command is that in your error results that you get, if you set these up where like, if we change this again, we can say $test should be 1, but if we say it should be 2, if I could type. So notice this time, see, expected 2 but got 1. But the nice thing here is, imagine 1 is like the output of a command. So the nice thing here is like, you don't have to go back and try to figure out like what went wrong with this. So like you'll immediately know, hey, like say you were testing, you're doing a screen scraper and you're trying to pull from a website. And writing screen scrapers is always risky because they could change how the site format works. So you can have tests in there that say, I'm expecting when I go to this web page and I pull out this table that this column, this header over here is going to be, my employees, because I'm screen scraping some old application that doesn't have an API. But if that changes and they change it to my compatriots, because we all decided my employees wasn't inclusive enough, then it will say right there, like expected my employees, but got my compatriots. So without you even having to debug the code, you can look there and see, oh, something changed in the website. So I know to go there, fix that, and then get the test working again. So that's like just an example of one of those things where should really helps because it gives you more information than just simply a throw or an exception to have to dig in. You'll get this into your test reports and it's a much easier way. So that's a really nice thing about should in addition to all the additional items that are there. So sometimes if we have multiple tests, it also works we might want to repeat the same thing. So here I'm going to do test equals 2, but maybe I don't want to repeat this part every single time. So for that, then what we want to do is we want to have a way so that we don't have to repeat ourselves over and over again. And that's where the before all and after all blocks come in. And I'll let Jaap talk a little bit about how you set up tests a bit more to prepare so that you don't have to repeat yourself constantly. Oh, I guess we should probably also talk about dry versus damp. You know, do we talk about that? I can't remember. Basically, dry is don't repeat yourself. Most people know that. Like the idea is like, ideally you don't repeat the same piece of code because if you ever have to change it, you have to remember all the places that you specified that. Whereas when you start with PowerShell, like this is why you write functions, so that you can call the same function over and over again, rather than cut and paste that code in 5 different places. And if you have to change it in 5 different places, forget one of them, which is more important in PowerShell than other languages because PowerShell is not a type-safe language. So there's often not an easy way to find all the references of something that you'll change. And so similarly, when you're doing tests, it helps to be able to reduce how much times you do the same thing over and over again. So we have tools like for each, we have tools like before all and after all. But when you're writing tests, this is a philosophical debate, but I believe that you should write tests to be damp. And this is a term that's known as descriptive and meaningful phrases. The idea being that you should, again, the idea for me is I feel like tests are for people not only to verify that the application works as it is, but it's sort of like, to me, tests are like your contract. I'm saying, this is the functionality that I'm writing, this is the functionality that I'm exposing to you, and this is what it should do. And when you come into an open source project or anything where somebody has written tests in that way, it's great because I don't have to even go to the source code to try to figure out what is he trying to accomplish with this Byzantine crazy code that does 5 loops. I can go to the tests and I can see, okay, this program should need to do that. And when I run the test, then I can step through the code that accomplishes what that test is with debugging. And it makes it so much easier for me to learn a code base, to get up to speed with it and understand how it goes. So if you write your test with the idea of descriptive and meaningful phrases, your tests don't have to be like where it's okay for some repetition in tests, especially because sometimes tests have different parts. So if you keep them kind of separate and descriptive, so it's more important for the test to be readable than for it to be completely like perfectly, only one reference for any one thing, in my opinion. Some people disagree, but that makes it so that you can really be able to have tests that are easy to read, because tests are for developers. They're not for computers. Like they're there for us to help. And the better we can read our tests and know them, the better we can change them when we need to and understand what those changes have as impacts. So now that I've completely railroaded you again, as I do, that's my job.
You mentioned changing the test. Would you, when you're changing tests, would you change your code at the same time, or would you just change tests? How would you do that?
It depends on the type of change, but it also depends on your philosophy. So there's like the philosophy of test-driven development, where you write the test first. You write your test like I did there, only test is the command, and it should fail by default because I haven't written the code yet. But that's, again, the same thing. We've established our contract with the business. This is what the code is going to do. This is what you are going to pay me to do, and we have written into the contract, my whole job is to make those tests pass, and once I do, you send me my check. And if anything changes, that's a change order, and that's where I make the real money. But so you can kind of take 2 approaches. You can do that, and that works in a lot of times where you have very clear requirements, you have very good things. But sometimes there's times where, like, if you're working against an API, if you look at my most recent, like, Microsoft MVP module, like, you're just hacking away at that thing because you have no idea what's going to come back. Like, you don't know what the test even needs to be. So sometimes it kind of works into a stage of my general personal process is I usually just hack away at it first. I try to get something that's like a minimum viable product, and then I write the test for that. But then once I have like, okay, this is the approach that I want to do, and at this point maybe I've thrown it away 2 or 3 times. Like, no, that's not the approach I want to do. And then like, oh, actually there's a better way to do this. But if I do that, if I write the test first every time, I have to throw those tests away every single time. So once I get to like kind of like a minimum viable product that I'm like, okay, I'm pretty sure this is where I'm going to go. That's going to be stable. I'm probably not going to throw this away and start over from scratch again. Then I write my initial test for that, for what I want that surface to be. And then everything going forward from there, I write the test before I do the thing. It's really good for issues. Like when somebody files an issue with your, in your repo, a great workflow is you start a new branch, and the first thing you do is write a test that reproduces whatever that issue that person was having. And then you write your code to satisfy that test. And then once you do that, when you go forward, again, it's not 3 months later, but like, 2 years later when you don't even remember that you did that. And you go back and you change some other part of the code and suddenly this weird esoteric test is failing again. You're like, why is that test failing out of nowhere? And then you go back, it's like, oh yeah, that's right, because there was that weird esoteric thing that I had to fix. And good thing I left that test there because it's catching that thing I totally forgot about. Module fast, there's a ton of tests in there because that happens to me every single time I change something in module fast because it's a very complicated PowerShell script. And because I don't have all the advantages of type safety and stuff, I always break something. And I'm always mad at my test the first time. I'm like, why did I write this test so bad that this thing that I'm changing that has nothing to do with what I'm doing, why did that test break? And then after like an hour or so, I'm investigating, I'm like, oh, I guess that is related. Huh, well, it's a good thing I had that test there,
I think you're a better developer than I am because I just push it to production and YOLO'd it out there. So
I do that too. Don't get me wrong. Like, on my personal projects where there's no there's no timeline or deadline. It's just me messing around with the better way to install modules. Yeah, but, definitely don't look at my production stuff. I'm not going to guarantee that's all got tests on it, but in short, yeah. So whether to the original question, which we will address in about 45 minutes. Just kidding. Whether should you change the test first or should you change the code first? It depends on your style, but only change one at a time. Change the code and see if it fixes the test. And if it doesn't fix the test, then verify your code's what you want it to do, and then go and update the test if it no longer is relevant to your code. Like, if you're like, oh, this was doing this, but we decided to change how this works, so now the test should be this. I personally generally, like I said, if I'm resolving somebody's issue, then I'm going to write the test first and then write the code to pass that test and fix or fix whatever's in my stuff that then makes that test pass. If I'm writing a new feature, if I'm like, oh, there's something new I want to do, then I'm just going to hack away on it. And I'm just going to be like, okay, I've got this, because I don't really know maybe what it's going to look like. Maybe I'll figure it out that, it's better to do the command line parameter this way versus that way. And then once I have that, then I'll write the test. But I'll never do them both at the same time. So.
No, that was also was a leading.
I mean, I could have just said that for like 2 seconds, but that's that's not how I roll here.
I know. But to touch on what you said about not writing your test first, I'm also on team. First, try to get something out there that actually works, and then write tests. At first, when I got started with testing in general, I thought that if you're doing test-driven development, you always have to write your tests first. But that's just one of the approaches. You can also come out with something that is functional and then come up with tests. It's not a necessity for TDD to write your tests first. So that is something that I was very happy about because I could, for the life of me, I don't think I would be able to come up with tests before I have actual code. What were we doing here?
I think we're going to go into before each and after each, or whatever you want. I mean, I'm not going to tell you how to live your life, Jaap.
I don't know.
Not in front of these people, anyways.
Question.
Yes.
Can we go into before each and after each?
I don't know how they work, so you're going to need Jaap to do it. It's outside my specialty.
Yes, we can. But I don't have the creativity to come up with code.
You don't have the idea for what to put in there?
No.
Think about like do this as your arrange for like multiple different tests.
Mm-hmm.
$test equal 1.
Yeah, there you go. Natural.
Change one of your tests.
So $test equals 1, and then your works and also works could be, or even better, make it a hash table, and then each test can be a different property. Don't tell him. Don't tell him.
Can you do the live coding of this one?
I can do the second half, yeah, sure. All right, so we have so an example of this isn't like more typically what you do, but the nice thing about a before each And the difference between before each and before all is before all this is simply like for each of your tests that are going to be in this particular section, whether it's a describe or a context. Oh, I forgot. So in addition to describe, you have this option for context. And so context doesn't really mean anything. It's just simply an aspect of another way of organizing. And you'll notice like if I put these tests in, well, we'll worry about that later. So it's just another thing for like organizing. And so what I typically use context for is like, if I'm testing that like, if I have something that's like testing against like a file system provider or something like that, like one of my contexts might be on Linux, one of my contexts might be on Windows. And so just different ways of organizing things where they are. But context is functionally, for the most part, at least for the part that you matter, it's basically the same as describe. So it's just another way of like, think of it almost like a folder. Like this is a folder, and then this is a folder, and then my tests go into that folder. And so in fact, it'll say, right, if you hover each of these, they do have good IntelliSense. So it's just a way of grouping things.
Go within describe?
Yes. I mean, well, actually, I don't know. I mean, we could test it, but I think colloquially, typically you do like describe is usually your top because you're saying I'm describing my test, and when I'm just doing this test within this particular context, this should happen, this should happen, this should happen. In this particular context, this should happen, this should happen, this should happen. In the PowerShell engine, it's in the Pester engine, it's just a way of like it'll organize things, but it doesn't really have any specific meaning in the software in terms of how it get executed. But as we talked about, like we want these to be things that we can show business people and non-technical people and kind of get an idea what's going on. So you can use context to arrange those, and however you choose to use context is up to you. It's just another container wrapper.
The answer is yes, it does need to go into a describe.
I was pretty sure that it did. I mean, stuff changes all the time. It's like, turns out in Pester 5.2.3, they fixed that or whatever. But so
That is actually one of the changes that just came out, is that they no longer support PowerShell version 3 in the latest Pester. So they're really,
in 5, like, was it 5.5.4, I think now, or 5.4.5?
something, the latest
Find
one.
out. It is 5.5.0, yeah. So for this, for the before each or before all are just ways. Remember I was talking about like the dry versus damp? This is a way to kind of be dry. Is rather than write test equals this in under works and under also works and all of these, rather than having to rewrite it under each single one of these, you can define it up here and just know everything in here, this code's going to run first, and then it'll do this, and then it'll do this. And we can I'll step it through in the debugger to show you like what that looks like. And so, so here we're going to test test.test1 should be 3. And let's name these right, test1, test2, and just for fun, just to show you.
And still the equal sign at the top.
Oh, really? Oh, is there a bug there?
Yay! I just need to step away, then I can actually look at what I'm
I know. It's so, like, when you're under the gun, you do the dumbest stuff. I know, I get it. And so, let's see, but we have this nice little problem tab that'll also let us know this if you weren't aware of that. And so, yes, so there test equals. Okay, so test1.test1 should be 3. $test.test2 should be
4.
It's funny you mentioned that because $test.test2, just to be sure, should not be 4. So this is a kind of good point. It's like it's also important. Like in addition to these are what are known kind of as assertions. You're asserting that it should be this, but it's sometimes good to do negative assertions. Like a really common one should not be null. This is a really good one to do, especially in PowerShell because we don't have any kind of we don't really have a good way to do nullable reference types. Which, in long story short, like we don't have a good way to make sure like null doesn't happen in bad places. So this can be a very handy one in like a bunch of tests. Like sometimes, like if you're querying against an API, if you're writing a module that queries against an API, something that could be just as bad as the wrong result is no result at all because they changed the API. But your code's not going to know that because nowhere in the process were you expecting for that null to be. In fact, what is it? Like null is like considered like what, the $2 billion mistake by the guy who created it. And it's just simply because people just generally don't understand the aspect of null and account for it. And especially in PowerShell, where we, the whole idea, a lot of the idea of the language is that we can be lazy so we can just get stuff done. But we tend to be lazy about, we don't always check that this thing is actually not null or that kind of thing. And we don't have any ways of protections to put things into the code where the compiler or the script interpreter has a way to ensure that there's not going to be a null, so we don't have to worry about it. So since we don't have those safeties, we have the ability to do something like that. And so this also leads to another kind of small philosophical discussion is, should not be 4. This also leads to another kind of philosophical discussion is, should you have more than one assertion in a test? And this will be just, again, this is another, it depends what works for you. Some people say every test should only have one and only one assertion, because otherwise sometimes it's hard to tell what's wrong with the test. My argument is that I think you should, like, the test should be for a particular functional area, and if you need multiple, like, functional things to test the same thing, like, if I were doing this real world, this would be probably one test for me. I would have my arrange set up, and then my assert, I would have should be 3, should not be 4, test 2 should be 5, and test 2 should not be. I would do all those in the same test, because, and primarily that's because Pester is very good about giving you the information about what happened. It's not just going to say test failed. It's going to say at this step it should have been 3, but it ended up being 4. And so because the way that Pester was written, that you get that kind of descriptive information, I'm generally okay with having multiple shoulds in the same test as long as they're all related to the same functional thing we're trying to test. Basically, as long as they still relate to that it, and that it is not the entire module works, like, you still have to scope it at least a little bit. I think it's fine to do multiple shoulds. But this is another one of those philosophical debates. And this is always, I think, one of the trickiest things about testing is because it's not like production code, like there's not so much like a style guide per se, because it really depends on what you're testing. Like, you could say like there's a lot of wrong ways to do it, so to say, but there's also like not really like one right way to do it. And this can be really frustrating. This drove me crazy because, like, as we talked about at the beginning, what's a unit test versus an acceptance test? What's an acceptance test versus an integration test? How do I wanted really super rigid definitions so I could very clearly say this is unit test, this is an acceptance test. And they don't exist. You just have to accept that they don't exist. Things that are unit tests sometimes act as integration tests. Some things that are integration tests sometimes are end-to-end tests. We just have sort of general criteria that let us kind of put them into buckets so that we all kind of know what we're talking about. But the big thing is, like, if you try to draw really hard lines, unless that's your team, if your team writes up definitions of tests and what those are going to mean, then great, you should do that. And now you as a group have decided what your very specific definitions of tests are. But there is no like universal definition of these tests. And you'll see this because you'll see people write like smoke tests. People come up with new tests, like they come up with like new flavors of ice cream, like just to be fancy. It's like, oh, I've got an inversion test. And I'm like, well, because I don't need more terminology. Can we just like keep this simple? That's my opinion.
But I mean, the test that you suggested earlier for the one weird little bug, that could also be considered to be a regression test. So you don't regress back into that.
Yes, I like to call them regression tests, so you don't regret making that change. Yeah, but like regression tests, like that's a good way. Like regression tests are unit tests, or they are integration tests. But the reason that you wrote it was because you had an oopsie, and you want to make sure that oopsie doesn't occur again. You don't. Again, we always like to say in IT, like, it's okay to make mistakes. It's like you drop the production database, all right, fine. Who has not done that once? But if you drop it again and you didn't learn from your mistake, that's not okay. And so same thing with this. If you write a code and then do that module fast all the time, I do a thing, .o doesn't translate correctly. Okay, well, I wrote a test so that doesn't happen again. And if it does happen again, that's on me, that I did not account for this situation to happen again. More so because in 6 months, I'm gonna completely have forgotten like why I even wrote that code in the first place. There's so many times I've written code and then like fixed something, left a comment in there that said, this is why I did this. And I come back and I'm like, that's stupid, that's been fixed by now. And then I go back and I fix it back and it breaks it again. And I'm like, and I spend like 3 hours working, I'm like, oh no, like, there was a really good reason that I did this and I didn't even trust myself on my own stuff. So be good to your future self is what a lot of this stuff does, especially when you feel super confident where you're like, I'm always gonna remember this. I'm gonna know how this thing works. Like, yeah, that just comes with experience. Yeah.
If you want to see an example of repo that comes with a lot of regression tests, look at the PowerShell repo.
Yeah.
If you go through the tests and then you look for a file that contains KB or NS, they're usually regression tests introduced specifically to make sure that you don't reintroduce something that goes.
Oh, do we lose our Wi-Fi here? I'm amazed we made it this far without it.
So just to repeat the comment we got from the audience, The PowerShell repository itself also has a lot of regression tests. So Justin is now going to connect to Wi-Fi.
Maybe.
Maybe.
This is what the backup plan is. Oh, we got lucky. Okay.
Excellent. And going to take a look at the PowerShell repository, because there's apparently a lot of regression tests there. So we're going to look for KB.
Do you mean PowerShell Git, like just a regular PowerShell repository?
PowerShell. And
We'll
the
bring up
reason
the
that
fancy VS Code web editor
this
here.
unknown audience member mentioned this is because he's also a contributor of this repository.
He might have been burned by said same thing. Yeah. Yeah. And so one thing you'll find here is too is like, again, the vast majority of PowerShell is written in C#. Almost all the tests are written in Pester. Because what are we trying to do? We're trying to test the, how people are using our application. This is another big debate. It's like, should you write unit tests for private code, stuff that's not exposed to anybody? Some people say yes, so that you have every little coverage. And I used to be on that side. More and more, I've moved to the side of no, you shouldn't. You should only write them for public methods because your private stuff is just an implementation detail. If you change that, it might be nice to have like a little utility test, especially if it's a really complicated function to get you to the end result. But the ultimate thing is like when your person runs test path to this path, it either works that path does or it doesn't. Anything about how it does that in the end is immaterial. So if you have the time and the patience and unlimited time, as we all do in development, then yeah, I guess you could write those tests. But really, when we're under the gun, you want to write the tests that have the most value. And those are going to be ones that test the external side of your code. It's going to be like if you're writing a script, it's going to be the ones that just run your script with certain parameters and you have a certain expected output. If it's a module, then you want to test the functions inside that module, as said. So here you see, this doesn't test like the C# class that runs this and makes sure that the C# thing has properties. It literally just runs that git sim instance, basically does the assert, sets up a mock environment where it can actually run that sim test, and then run the git, check the results, and then this is one of those cases where they're not using should, but there's reasons sometimes you don't need to. But you see, this is just an example of an assertion there, like, hey, if it worked and it didn't throw an error, then we're good. If it didn't, like if it throws an error, then this test will fail and we'll know that something went wrong there. Yeah. It is all before all block. Oh, I'm sorry, I wasn't even into the it test yet. So yeah, so here's an example of like, this is like the assert, This is a very complicated aspect of like, if this is a Windows test, you can skip them because, we don't have sim stuff on Linux, so there's no point running this test. So this does all that setup, gets it up, makes sure it gets all the information, imports the module, does all that setup, and then after it's done, does a bunch of teardown, like it removes that sim test module. If it can't remove it, write a warning so we know there's something wrong with our test to fix it. And then we get down into the actual it statements that do the testing. And so you can see, as usual, the it statements are very easy to read. Again, this is internal PowerShell stuff. Those of you who probably may have never even used the sim commands before don't know anything, but you read this command, this test, you have at least some idea of what this is doing. The sim test module, when we're doing module of test, it should have loaded. So what does it do? It does git module. Everybody knows how git module works. It verifies the module there. And the result, like basically the result, not only are we making sure that that module actually came back when we do git module, but again, because everything in PowerShell is an object, on that object is a property, which is where that module is. And we want to make sure that the module that we're loading, earlier it was set up what that module directory is. We want to make sure the module we're loading is the actual module we were trying to load. Yeah?
Do you have to set a script scope variable there if it's going to be loaded with the for each?
So it gets a little tricky. Most of the times if you set like a script scope variable in before all or after all, it will be in the scope of your it statements. In this case, it's not being set here, it's being referenced.
Yeah.
Maybe I missed the part where you said.
But do you have to specify as a script scope?
If it was defined up here as like script module, I'm sure it's, let's see.
Is there another reason why that one in particular is like that?
Not usually. A lot of time it's just being explicit, like it's being, like I personally like if it's coming from before all, I tend to like to put the script modifier on there, just to be clear to myself that I'm pulling that from up there and it's not something where it's in my current it scope. So like I like to put the script on there to remind myself that that variable is coming from somewhere else than my current block. Because like I might come back to it and be like, oh, I forgot to define this variable, and then write it when I was like, oh wait, actually it was already defined up here. So that's just sort of like, because PowerShell doesn't really have a really easy way a lot of the time to like go to reference and have it be correct, because it's not like C# and stuff where all that stuff is type safe. That's just something like I personally like to put the script there to be explicit, just to remind myself that it's not coming from the particular it test, it's coming from the before all. But you don't have to most of the time.
It might also be worth noting, say that a lot of these tests have been around since PowerShell 3 or PowerShell.
Oh yeah, I don't.
They've also been migrated through various versions of Pester. So going back to the PowerShell repo and checking out the test might be good to get like inspiration for how you can set up or how you can arrange, as Justin was saying. But I wouldn't take it as gospel, right? I wouldn't like copy the style of the test.
Yeah. So what the beginner PowerShell user was emphasizing to us here was that that these tests were also like, if I don't have, this is the web-based version of VS Code, so this is actually running entirely on my browser. I have an extension that I love called Git Blame, which basically, if you're in a Git repo, you click on any single line and it'll tell you, who wrote that code. It'll say, I'm like, because my favorite is like when I go to it, it's like, who wrote this garbage? And I go to it, it says you 3 years ago, But if you were to look at these lines, like a lot of these tests are probably like originally like 4, 5, 10 years old. So, and Pester has evolved, and the styles that we do Pester have evolved. So yeah, as basically the audience member was saying, don't take these tests as gospel for like the right way to do things just because they're in the PowerShell repo. Just like any kind of test, these are the tests that work and they were good enough at the time. And they probably like, this was the best way to write it at the time. But since things have evolved, especially up into Pester 5, these might be Pester 4 tests that were just like shoehorned into 5, but not like fully rewritten to be like the nicest way, because it just wasn't worth putting in the effort. Yeah.
Or the refactor may have been automated, right? So
yeah, or yeah, the refactor process may have done, like I said, just finding that code that wasn't in before each blocks and just putting it in and then making sure it still worked. Yeah, do you have a question? Good. See that button right there?
That's too small. Can you make it bigger?
I need zoom from the cameraman. So yeah. So if you're in GitHub, we'll do a little aside here. So in GitHub, if you're on any repo, they actually made a really nice video of demoing this. But I'll just go back to PowerShell here again. So if you're in GitHub, if you're in any repo, all you have to do is hit the period key, and that is a browser tie-in that will automatically redirect you to github.dev, which loads the repo in. So because all right, well, let's do a side thing, and we'll talk about Pester tomorrow. This is VS Code running in your browser, because VS Code, if you don't know, runs on Electron. The VS Code that you see on your desktop, even though it really looks like a super native app, is actually a web page. All VS Code is all web page. It's web pages all the way down, people. And it runs into using this special engine that's designed to be able to work on a desktop. That's why it came out so easy for it to run on Linux, runs on Windows, runs on wherever, because it's not used, the core engine is Node.js, and it runs as a web page. And so as a result, it can run in a browser just as well as it runs on the desktop. And so they, a little while ago, made this thing where basically you can do this and it's running in your browser. Now, because it's running in your browser, you can't get a terminal because your browser can't run x86 code. But you'll notice here it comes up with this thing called GitHub Code Spaces, which is a separate thing. So if you hit comma instead of period, that will bring up a code space. And what that does is basically spins up a virtual machine in the background, runs this headless in there, and in that you get a full environment. You can run PowerShell commands, you can do all that kind of stuff. But when you just want to do something like this and you want to do like really quick searching and you don't want to use the GitHub interface and you want to be able to just quickly look at documents, this is basically sort of like in a way like a fancy GitHub UI. And like you can look at files, you can get all your syntax highlighting, you can do all that, and it all runs literally inside your browser. It's running inside your browser's Chrome engine or whatever. Yeah. So yeah, so as far as the tests go, like we were just showing some examples of the ones here in the PowerShell directory, but you can see that a lot of these tests kind of fall into, now the performance tests are written in C# because, you know, that's what we need for performance, but that's an example of like a C# test, but you can see of ultimately this kind of talks more into the TDD types. I think actually these are setups, but where's the assert? All right, never mind, forget it.
Can you look for the KB one? For the regression test? That's how we ended up here.
No, they're usually in the documents, right? So if you
Yeah.
enable the either
Yeah. So the mention from the audience was that a lot of these sometimes a lot of these tests are actually like in line with the code. It's just like an easy way to have like a reference to tie in and have that information. But the thing here is like, again, if we go to like just an example of PowerShell community, add type as an example. These are, I'm still in the source, I'm not in the tests. Get out nano, get out these, PowerShell, engine, basic, how attributes work. And so here's an example, like they made a script here, brought in the script, and then here's that thing testing, and so here we go. If we do this, it should throw with an argument error. So we're testing that, if there's no argument provided to a script that requires an argument, then it should throw an error. So again, like I said, like without really knowing PowerShell too much, I mean, there's a lot of, and this is an older test, it's got a lot of this extra stuff in here that you probably don't need these days. But you can see, again, another test that's not written of like doing a unit test, not test, all this is written in C# in the back end, it's a C# attribute, but we're not testing the properties, we're not trying to initialize it in that way. We're just simply saying, if somebody runs this script, then we expect this result, and you can read that. So keep that in mind as a philosophy when you're writing tests, that you'll be able to see that. And when we get to like the tests that we'll show a little bit later, that's how we'll do them forward. So now that we've gone like into the minds of Moria before we came back to our normal basic beginner test here again. So what I have here is I have a before each, that basically what will happen is that each time this will run and it'll reinitialize it. And one way that I'm going to prove that is I'm going to go in this test and I'm going to say test2 equals 12. So I'm going to rewrite this, but because, let me get the terminal out of the way here. So, but because this part reruns each time, this will get overwritten by the time we get to this point. If I make this before all, then this would break that test, because before all only happens for everything that's in the block. Does that make sense? So if we go back to the terminal here, we'll see if this, where did I screw up? No empty back 5. That should not, yes, thank you. I was showing that demo there. But see how fast that was to find that? It was simply like expected null or empty at this line, and in VS Code you can click there and it'll take you right to the line where your error was. And it's like, okay, should be null, expected to be null but got 5, and then I was like, oh, that's right, because I wanted to be 5, so I just wrote my test wrong. But again, you guys picked up on that super fast. This is one of the nice things about shoulds. If it just said throw, it just said unexpected exception in test 2, it's going to take you an extra 15, 20 minutes to figure out exactly where that is, and that can add up. So that's why a lot of these things like should was written, is to make it much easier to get that information. So now let's try that again. Okay, so this time our test completed. I'm going to do output detailed, and we have our individual tests, test 1 and test 2. If you want to get really crazy, you can go diagnostic, and this will actually show you the whole testing process. And so you'll see where it did the test discovery, found my test.ps1 file, found the 2 tests, did all that extra work, and then ran the actual tests. And I think there's a version of this view that you can run. There's like a really diagnostic one where it'll actually show like the before each part running. So, but you'll notice the test still passed, even though here I set test 2 to 12, but here test 2 should be 5. So if I change before each, and also you'll notice the scope here, even though I didn't set this at script scope, it did carry through to the other ones. Most of the time, this doesn't always work, so I usually recommend at least at your before each to make those in script scope, but sometimes it'll work just fine. But the thing is, like, this makes sure it at least certainly gets reinitialized before it moves on to the next step. So if I change this to, first of all, again, every time you make even a little change, hopefully your tests are fast enough that you can just test them. Okay, so we're still testing, good, that's good. I think there's a minimal output that makes this a little bit tighter. There we go. And so if I change this to before all, as we talked about before, now the test fails. And the test fails, surprise, surprise, at this line, it should be 5, but got 12. So this is a good lesson in keeping your tests, we'll like to say sort of atomic. Like the more you can isolate a test and don't bleed information between tests, the less likely you are to introduce like bad tests. And then now you spend more time debugging your tests than you spend debugging your actual code, which never happens to me, I swear to God. So this is just a good example. See, like that's non-obvious, like that's the problem. And so if you're much more specific in your test, like you don't try to change things, and that's where these before eaches can come in handy, because what you can do is you can do a before each, and maybe you have like a base thing that comes on, and then maybe you start doing your modifiers. So we're just doing a simple example with hash tables, but this could be like you grab, you have a mocked version of a database and you grab a database table. And in that table, you go through and you want to run a command that like sets and changes like, the person's last name, and then verify that that last name changes. And then the next line, you want to change their first name and verify their first name changes. But the thing will be is that if you use before each, then you can have a before each that drops that table and redoes it. So you have a fresh test environment. You may hear the term fixture every once in a while. It's not as popular in PowerShell. In PowerShell, we pretty much call mocks and fixtures the same thing. And again, all the terminologies bleed together. The idea of a fixture is just sort of like, it's like building up our scaffolding to then do our test. It's just like setting up an environment. Typically in PowerShell, we just call those mocks. Like you're setting up an environment, you're setting up a mock environment so that you can then run these tests and make sure that the things work as expected. And so we have our test here, and if we do test 1 equals 12, test 1 should be 12. Actually, a better example would be like 6 plus 6, because there's no point in testing something that you're just directly assigning. But we do this test, and we switch this back to before all. So that looks right. So now our test passed. So we have our basic scaffolding there, and we can test sort of our more specific example here and verify that one. But you'll notice the next one, it automatically like reset. In fact, sorry, this was a bad example. I should have done test 2. And where did I mess up? Thank you. I don't even know why I'm up here. Why don't you guys come up here and do this? Well, not with that attitude. Somebody said nobody talks as fast as I do, so. So we have this set up here, and so this kind of gives a better example. So here, test 2, I could test that, but then implicitly, because I have before each here, it resets this. You'll see a lot of this like when we go to the module fast test. You'll see I do this a lot. I'll set up a whole environment, I'll get it where I want it to go, and that way I can test all these different examples and iterations. And especially once we start getting to the stuff of doing for each loops in here, which you do in a special way in Pester, that makes it really nice, because again, it's me not having to repeat the same test over and over and have to rewrite all those things, but having it in a descriptive way. So, being dry versus damp, as we talked about earlier, like dry is good, you should always try to be dry, but they're not mutually exclusive. You always try to be dry up until the point that it makes your test impossible to read. And if it does that, then you should err on the side of being damp. You want tests to be descriptive and meaningful. And if doing don't repeat yourself makes it so that they aren't that, then you've gone too far, in my opinion. Or maybe you should restructure how your tests are set up so that you can do them dry, but also still have them be readable. So that's basically how before each works, and then after each works the same way. And a fun thing you can always do here to test this stuff is you can always throw right hosts in here, and they'll come out just fine. I always like to do magenta when I'm doing debugging. So now when I run it, you can see the before happened twice, because it happened once each time it went through this block. And if I was running debugging and I stepped this code, you'd see it do that. And when we have that each time, we get through there. And so this is kind of an easy way, like if you're learning the structure of Pester and you kind of want to get used to the DSL and how it steps through things, there's no shame in throwing a right host in there every once in a while just to see that it steps right. The one thing though is that all the output gets collated and done at the end. So even if like this part happens here, you won't see anything down here until it gets like all the way to the end. So there's a few little things about it, but it can be kind of helpful to, and you can always just throw a thing in here if you're not using regular debugging. But you can always throw a thing in here like, why is this, this the way that it is? You do, test 2. And so we can see like there, this is your console log of PowerShell, And I have no shame. I do that all the time. It's fine. Like don't let anybody shame you into not doing that, as long as you don't forget to go back and change them. I usually, like when I do these, I do a fix me right ahead of them. In VS Code, I have an extension where if I do something like this, it puts it in my problems view. So like it'll throw an error until I go back and fix it. And I do this it's an extension called to-do tree, which is a whole separate thing, but I recommend that. It should be part of the PowerShell extension pack that I curate. So, but the core message here is that with the testing that you have, when you can do a before each, this is just another example of like how you can scaffold things out. So, yeah, do you feel like doing just testing a commandlet, like try test path?
Yep, sounds good. What are we testing with test path?
Why don't we just test path? Make sure that it works. How about we have so here I'm the business person. It's like I need to make sure test path works because I use it in my script, and if it doesn't work, it's going to throw weird esoteric things because all it does is come back and true false. And so if you haven't tested it for me, my part of the script isn't going to work. So I need to see a test that whenever you commit changes to your test, that this code works. So I want to see tests that tell me that with test path, first I want you to create a file somewhere. Temp file, I don't care. It's your choice as part of the test. But when you create that path, I want you to test that path, and the thing that comes back from test path should be true. And if you do that same path and you put a unicorn on it, I want it to come back false.
Fair.
So first write me, so this would be an example, like either he could first write me the test to do this, or just like, I'll see it all at once, So let's assume we've already written test path. We did it through code review. We looked at code test path. I'm like, okay, this looks good. Like we did the thing. We decided we wanted true false. We decided we didn't want it to return the path or not return the path. We decided that we didn't want it to throw. We're going to write another command called resolve path for that. We decided test path we wanted to be like, it never throws an error, it just simply returns true or false. So now that we've all agreed and we wrote the code and we did a proof of concept, it's like, okay, now we want to make sure it stays this way. So if we ever come back and we edit this and we're changing something and suddenly like, have you ever, I feel like there's nobody in here who has ever committed the sin of like, in PowerShell, because everything gets output, like you'll put something in quotes something and not realize, or you'll use like array list or something. You'll do an add, and array list returns a true if you do an add, if you don't put it into a null. So suddenly you're doing a test and you look at your array and you have the result of your script is 15 lines and 12 trues. And you're like, where are these trues coming from, right? Yeah, is there anybody who like has not run into that? Yeah, people have seen that problem. So, look, some of us are still learning, okay? We haven't learned about generic lists. The question was like, but why would you use array list in the first place? And the thing is, some of us are just learning. We haven't learned our generics yet. We haven't learned how to use generic list, et cetera. Yeah.
You committed to memory the code to put in a unicorn.
Look, the thing was like, I may not know how to use generic list, but I do know the Windows shortcut key to put in emojis. And the thing is
that is Windows dot. So
Windows dot, yes. Dot is the magic
dot.
key. Dot gets you to GitHub. It does that. I believe it makes julienne fries too. Like it's a great key. It does all. Yeah, you beat me to my joke. Dang it! Took the wind out of my sails. He said priorities, and that was literally what I was going to say. Unfair. All right, so here we go. So I'm looking at my test here. All right, we're gonna, I'm gonna make them come into my stand-up here, and I'm just like, all right. So test path should pass, and unicorn. All right, close enough. So test path, file path should be true. Okay, where's file path coming from? Are we there yet? Do we have that in our?
Yeah.
Okay, we're sorting that. And file.txt. Okay, so but you're gonna put that file like wherever you run Pester. I hope you're gonna clean that up.
We could.
I would like you to clean that up after the test. I'm okay with you putting it in the directory. I would have preferred a temp directory, but hey, I'm not going to tell you how to do your job. But I do want that cleaned up because I don't want suddenly a file.txt getting committed to my GitHub and wondering what the heck the deal is there. There we go.
Very, very demanding.
I'm starting to wonder if that isn't going to work. Can you just pass a string that way? All right, well, we'll find out, won't we? Well, why don't you just throw recurse in there for fun while we're playing with fire? All right.
That's clean enough.
All right, cool.
Next up.
I'll let you get back. Oh, is the test ready? Let's go back to the test. So, all right, we're going to test that path, and the path will be there. Okay, and the other thing, but I wanted the file path plus unicorn as a separate new test, that if you add the file path plus, because I don't know that your test path doesn't just return true all the time. Like, I don't know that you're not just blowing smoke at me. That was like, oh yeah, it's there, yeah, sure. So I want you to add a unicorn to that, and if that path is not there, it should be false. But this should be a separate test, because I want to see it separately. Because we are testing a different behavior of our thing. Like, multiple tests here could be that the file is there, that it has the correct path, not just that, that it didn't garble the path when we were doing that. It could be that there's lots of stuff you could have as multiple shoulds in there. But at a very basic level, we're just simply testing that 100%.
Yeah, I could also change that.
Yeah, but I want it to be at least like close, because I don't just want it to be like some wild thing doesn't work. So
Should.
there's also, so, and by the way, the should, all of these are fine. Should dash not dash be true, should dash, be false, should dash not dash be true. What's up? Oh, yeah. We're just going to do this one thing and then, yeah.
Is break time? That's early.
You have a syntax error somewhere.
Oh, right.
It, very important.
Yes.
Also, yeah. And honestly, I'm going to criticize the line 29. I feel like that rather than, well, we'll fix this first.
Looking for a variable that's file path unicorn? Yes.
You might have to put the file path in braces.
Oh, right, yeah. Maybe he doesn't like you.
I always forget like if Unicode still counts in the variable name, and I believe it does. Yeah. Some characters don't, like colons don't, but well, that's one way of doing it, I guess. Technically correct, the best kind of correct. We've learned about this. All right, so can you run it with output detailed so we see the actual test names? All right, so here we go. We got test path should pass, unicorn. Test path should not contain unicorns, demon. Both test pass. Well done, Jaap. You get your paycheck. So we're gonna take a break. Thanks everybody, and when we come back, we'll go sort of more into some of the more in-depth pesters, and we'll show how to use the Pester test extension for VS Code. So thank you very much.
So while Justin is hacking away, during the break we did get a question about testing. So when you're writing tests and you find out that one of your functions that you're testing is not only getting information but is also setting information, would it then be a good idea to split up that function as a result of you wanting to test it? It's also more of a philosophical question, but for me, when you are writing tests, it's also an opportunity for you to make your code better. So if you notice something isn't very testable, it can be worthwhile to actually make your code better as well at the same time. What's your take, your hot take?
Yeah, I mean, my feeling is like tests should be atomic as much as possible. Like you shouldn't have tests that require a sequence to run. Like you shouldn't have like in this scenario, like a scenario where like say you're doing an actual like end-to-end test. You want to make sure this actually works against like a database. And so your first step of your test is to insert a record, and then the next step is to change the last name on that record and verify that that happened. And then the next test is to delete that record. If you have those as 3 separate tests, if one of those fails, it doesn't prevent the other ones from running. And so like it can mess up your test environment. So those kind of environments, there's a couple different ways to do that. I believe that you should have a before all and an after all that reset the environment. First, make sure that there's no lingering things. Ideally, it builds your environment from scratch, but you can't always do that. So like if you have an existing database, it should at least make sure that like the test record you're trying to create doesn't already exist. Like resets the environment to a pristine state. And then that whole process of insertion, modify, and delete, that should all be one it statement with multiple shoulds. So once it inserts, then you should get it and verify it should be there. Then once it's modified, you should verify that it should have been modified. And then once you delete it, you should verify that it's not there anymore. But that should all be one it statement and not 3 different ones. That way that whole process is tested as an atomic unit, because that's the operation that you're doing. And if you're, yeah, did you have a question?
Related to that, I mean, if you have a test that has 3 steps like that, and it fails to the middle one, do you want it to go on and test the last thing?
And that's the thing. It depends on your environment, and so it depends on how you want to fail your tests. So typically, I have those where like you do the shoulds, and you can either have the shoulds like immediately throw and bail out, or you can have them like allow it to continue. And either way, that's what the after all is for. So the after all is there is that if it fails halfway through, the after all should be there to clean it back out, or the after each, excuse me, not the after all. So there's different ways you can structure it. The problem with those 3, with defining them as 3 separate tests, is you can never just click that middle one to run. If you try to click that middle one to run, you'll get an inconsistent result. And one of the nice things about writing tests is that, especially when you use tools like my Pester test extensions, you don't always have to run the entire test suite. Especially if you're working on a small portion, you don't want to run your entire 20 minutes of tests, at least not until you're at the point you're ready to commit the code. Maybe you just want to run the one small test over and over and over again. And if you have them as 3 separate tests, you either have to know how to run that as a context, or run that individual test. If it's an atomic unit, then you don't even have to worry about that. You can just rerun that one test over and over. Does that make sense? Okay. Did I repeat the question? I can't remember. I'm always bad at that. But in short, that was a thing of like, should tests be, when you have tests that have multiple steps, should those be multiple it statements, or should that be like one atomic unit? And this is another one of those engineer answer, it depends, or philosophies. My philosophy is I never think one test should never require another test to run. Like this test should not require this test to run. To me, that's like a code smell. If that's happening, then whatever you're doing there should either be in a before each, after each, or those 2 tests should be combined. That's just my general philosophy when I see that. So, all right. So Jaap's going to talk about mocking and some of the ways that we can do things. So we showed very simple, contrived examples of doing tests, but we were just testing for test's sake. Like we were running code that pre-existed. So in this case, we're going to actually have a module that does code that actually reaches out to the internet. It's a very simple function that it does, but our test is going to intercept part of that code so that we can at least verify that the basic logic of how our program works without actually reaching out and doing anything. And that's typically what's called a unit test, and that we're testing our unit of code, not interacting with anything else, just to make sure that it behaves the way that we want it to. Now the external behavior may be broken, like the server may return a different result, but that's not our concern at this level. And the nice thing about these tests is they're very fast, so you can just run them without having to have a whole scaffolding built out. And so they're really good for failing fast and making sure your logic works. And then later on, you can have a test that tests the same thing, but it actually like builds out the environment or something like that, which that test takes longer, but you only need to run that one like before you deploy to production, just to make absolutely sure. But you don't want to wait a half hour each time for that test to run. So we're going to demonstrate a way you can do that in Pester called mocking. So, yep.
Where's the mock?
And so this is the actual mock one. That's the test.
All right.
And we got to cancel out of the
Yep.
presentation. Unless you want to do your slides.
I don't think anyone. Is anyone here for the slides? There we go.
But you worked so hard on them.
Escape out. Oh, we have dogs.
We do have dogs.
Yep.
Slides are very.
Dogs. No. Let's see. More dogs. This was my favorite.
Yeah, that one was great.
Yeah.
I think it was one way at the bottom.
This one was weird.
Yeah, you get the AI and like you got to go full uncanny valley. Like you always got to have at least one of those in there. And we're up to 24:15, by the way, as was pointed out by a speaker. You're getting your money's worth. Like, what do you want from me?
Yeah. Dogs. Good.
Okay, dog's done.
Can see that you took on the manager. Wrong VS Code. Cool. So we have a module here. So we get the IP address. So let's just load the module. Is the module already loaded?
It should be loaded. You should be able to run it.
Sweet. So we do get IP address.
So if you're not familiar with that, ifconfig.me is a very simple site that you can run simple REST queries against, and it will tell you like what your IP address looks like on the outside, not what your internal private one, but what you look like the outside. So this is an easy sort of example where when you do invoke REST method, it'll recognize actually, it'll by the host headers that you're coming from PowerShell and not give you like a JSON result. It'll just give you a very simple result. So this is just an example of a very simple command that you can do, that you can write to get this. But let's say that like our company policy has a firewall that doesn't let us reach out here. So how would we test that? Or otherwise, you know, we don't want to reach out to that all the time. Let's say we were getting billed $5 every time we hit this thing. We don't want to hit it every time, just trying to make sure that our code works correctly. So,
and that's where we get to mocking. So once again, in our before block, we are going to import this this module, so mocks.psm, and we're going to make sure that it is actually mocked. So we mock it inside of the it statement. So we have the single unit, and we want to make sure that once we run get IP address, which is the function of mocks, that it returns that. Do you not have the extension enabled for run test?
I don't, but what you can do is just do, we have the breakpoint set, so hit F5, that should turn on the interactive mode.
Do you have FN turned on, or?
Isn't it? It's already going, it's up there, so you should be able to just do it, okay. Just do the invoke Pester, just run it in the console. So sorry, so this is what, in VS Code, if there's a mode called interactive mode, that's one of sort of the default debugging things that will watch your console, and if any script that you run hits a breakpoint that you've set, it'll just hit it, as opposed to like having to run the script directly. I use this mode all the time. I feel like it's one of the most underutilized features, as you can see, because he didn't know what I was doing. But so what we got here is that we basically started Pester. Pester's going through, it discovered the tests, and now it's in the process of running it. And so we did our before all, so the module's imported, and now we're at the it statement. And so now we're at the point where we're setting up the mock. So we're just showing that we're stopped there. So go ahead, sorry. So when you step in, now you're actually, again, this is sort of a little going into the weeds a bit, but when we're stepping in here, you're gonna see that now we're actually in how Pester is handling this, because all of Pester is written in PowerShell. And unfortunately, the way that the debugger and stuff works is not a really easy way to like exclude modules in their way that C# and Node.js can. So yeah, file a feature request, we'll figure it out. But so this is just showing you that we're actually stepping into an actual mock function. So I say at this point, just go ahead and do a run to skip all this part. But it's just to show you that you can actually step through the whole process that Pester does to take the code. And what it's doing here is it's basically taking invoke REST method and it's rewriting it with its own version of mock for the purposes of this test. Which you can do. Like if you've never tried it, you can just write function, you can do function, invoke REST method or test path or whatever, write your own version, and now your version is that command, even though it's in your command prompt. And so PowerShell makes that really easy to do. Not all languages do that, but because of that, it makes these kind of mocks really easy to do.
And we can see that this was not the most efficient Pester test we've run today, because it took over 100 seconds.
Because we were in the debugger, yeah. I might have, what was that, like the XZ compress? This is how that XZ compression vulnerability was that the library? This is how it was discovered, by the way, is that somebody was running performance tests against it, and one thing was like just 10 seconds, like 10 milliseconds slower than it normally is. Like, what's going on here? And he went in and he found that's how it was discovered. Like otherwise, it was just dumb luck. Sorry, weird aside. But so what happened here is that.
Yeah, no, go.
So what happened here is as we went there, so once it ran get IP address there, even though we got the same result, should be 11233444, we kind of skipped through it because we didn't, that breakpoint should be like further down in the script block. But what happened was that rather than actually running invoke REST method, it ran our script block. So if we were to put in there and we were to put in nope, like it would just return nope. So it didn't actually run, it didn't actually go out to ifconfig me and return an IP address. That's why, we just used a made up IP address there. It intercepted that invoke REST method call and did it here locally. So then once it was fed that back into the command, but because it was able to do it, it actually went into the module and told the module that that command is different. And so that when we did our result, when we do our test passes. So this just verifies that the logic of our command works. Hey, when we call get IP address, We expect it to go call invoke REST method and come back with something. We don't care what, we don't want to worry about like server fails or it costing us $5, any of that kind of stuff. So we just faked that part. We had Pester go in there and overwrite the invoke REST method part so that it would return whatever result we told it to, so that we could just verify that the logic of our module is good, and so the actual is there. So this is kind of a contrived example, but you can see a thing here where if you have like a longer process where you have something that like, a common thing here would be like, say you're returning an object from an API, and often you get it in this weird JSON format. And you want to take that and you want to build a new object that has better properties, like maybe the date is in like Unix time format stamp, and you want to change that to an actual like date time. Maybe you're combining two objects from two different APIs, and you want to make that all look like one unified. So you can mock the results from the actual calls, but you're verifying that the logic of how you build that object works the way that you expect it to. And you can do that multiple different ways. You could have the data coming in being different use cases, and you can be like, well, what if this data is missing? Does it still survivable for that? What if this one sends a negative date? Does it survive that? And you can do all that testing without actually having to go and fetch from those APIs constantly. So that's where mocking comes in real handy. And because of course it's running locally, like these commands run really fast, so you can have all these tests that happen locally very, very quickly. And we'll show some examples of that in module fast, of like what that actually looks like in like a real world situation.
And yeah, things that I've used this for personally is in some of the API wrappers that I've built, I wanted to be as PowerShell-y as possible. So it would take information from certain API endpoints, and we could pipe it directly into other API endpoints. And the logic, that was the logic that I wanted to test within my code. So I wanted to make sure that whenever it pulled something out of an API endpoint, and it would get back the data, the correct kind of data, because otherwise it would just throw an error if it wouldn't get the correct data, that it would follow through with the logic, and it would be able to call the next API endpoint within my own logic, and that way, see?
Yes, very much.
No problem. Yep.
Maybe I missed it, but what's happening on line 4?
Let's see. Let's go up to line 4.
Yeah.
You're importing a module.
So
Yes,
go
so
over
that
to
is-
the actual module. Yeah, I mean either direction.
Yep. So we stepped over. We stepped over this one. This was at the start.
Okay.
Yeah. This is an example, like you would be writing a module, you write a function, and it would have some things that would do internal calls. That could be like invoke SQL CMD. That could be, doing remoting. That could be, remoting the graph API. It could be any of those kind of things.
AZ module.
AZ, yeah, you could be calling AZ module functions, but you don't actually want to delete a virtual machine. So you could mock and just have it return as if it had deleted a virtual machine, but not actually go out and do it. But you can verify that your script like reads the thing there and make sure that it processes that correctly.
So the question was.
Oh, sorry.
Yeah.
Thank you, yeah.
No problem. I started answering, so this one was on me. The question was what is happening on line 4. So we're importing the module.
Is the specification of the module name parameter necessary if you're just trying to repeat mock command inside the function?
So the question is module name.
Mocking of the module name.
Yes. So what we're doing here is we're mocking invoke REST method specifically. I could have made this mock get IP address. And if I did that, because get IP address is visible to the environment, you don't need the module name. The module name says go into, because if you're not familiar with how modules work, modules have sort of their own sort of side scopes for like variables and that kind of thing that exists outside like your main operation. And so the module can have its own sort of information. And so if you have a variable set in like just your normal, like if you set test1, module's not going to see that because it's got its own side space. So that way like the module doesn't get confused by maybe some special variables you have in your environment. So what that does is that says for the invoke REST method that's in the module, rewrite that so that it has that. That's what the dash module name does.
So if you were to have two function in mocks.psm1,
Well,
completely different, but they were both calling invoke the REST method, you'd have conflict there.
Well, so what would happen is that you would call the next one as a separate test, and you would do your mocks separately for that one. Also, we haven't really gotten to it here, and we may not have time to cover, but there's a thing you can do called parameter filters, where with the mock, you can do dash parameter filter, and then you can do a thing that's sort of like a where object script block, where you can say only mock this if the parameter was URI www.google.com. If it was www.yahoo.com, mock it was something completely different. And so you don't have to mock an entire command every time. I mean, like, you do, but what happens internally in Pester is that if you use those parameter filters, if it doesn't match that criteria, then it just behaves like normal. So, does that make sense?
Yeah, what I would do is for different API endpoints, I would have different mocks just to make sure that I get the object that I want.
And we didn't repeat it. The question was, if you have, with this invoke rest method, the way we have it here, if you had multiple things that need to call that invoke rest method, doesn't that create a conflict? And in this case, it's because we're only doing the one command. Also, after this test is done, Pester automatically goes and resets that behavior. So your next test, if you had a separate like it statement and you want, or you had a separate describe and you want a different invoke rest method behavior, they wouldn't conflict because it's already been removed by the old test. It's very good about like making everything atomic, which we talked about before is very good for those things. So, yeah. Say that again, sorry.
Like before each?
Yes, so the question was, can a mock exist anywhere outside of and yes, like you can put in a before each, so a lot of my tests, like I will mock in the before each, so that all my tests, I don't have to have that mock each single time if I'm testing the same thing. It's like, if I'm testing like input validation, for instance, like I'll put the mock up top, and then all mine will be like just different variations. Like if it comes in this way, it should be this way. If it comes in this way, it should be this other way. But the mock is actually like up in the before all, yeah. So it can happen anywhere in the stack between the describe and the it. Like it can land anywhere as long as it's not in the discovery phase. So as long as it's inside some sort of before each, after each, or it. Wherever those are located, it will still be valid for the scope of your test.
If it's not in there, it will break. And
It will 100% break, yeah.
yes, but it works fine in Pester 4.
So, Jaap, I'll put you on the spot again. Do you want to copy and paste that return IP address, but remove the module name mocks and just make it so that it just mocks the get IP address command? So we'll mock publicly rather than privately. Does that make sense?
So you want to remove the module name and just make it
Control Z, Control Z, Control Z. Oh god, all right. Copy that sec. First of all, save. So I got on the timeline before you mess it up too badly. There we go.
Yeah.
Real quick, go to the timeline here real quick. Some people have not seen this, and if you're not aware of this, every time you save in PowerShell, it keeps a copy. You have like your own, even if you're not even using Git, it keeps its own little local copy. And click one of these older versions. You can go back and see the difference. If you were not aware that that exists, it's one of the best features of VS Code that was added about a year ago. And if you watch my optimizing thing, I talk about this a lot. It's fantastic. And so if you just get used to saving a lot, and this is like that Word autosave, but for VS Code, every document you do, it's on by default. You don't have to turn it on. It's awesome if you have never seen that. So quick aside. So what I was saying is copy like 6 through 14 and just make it a whole new test. Because again, we don't need to rewrite our test. That's a good test. So now let's make a new test. Let's get even more test coverage. So now, like, we can name this one, make this one, the public aspect of the module works. Yeah, so it's still return IP address, but yeah, like.
You're still in the view of the timeline.
Am I still? Oh yeah, I am. Thanks.
So then for the module, take out the module name mocks. Yeah, and just make that get IP address. So this is what there was a question about, like, what's that module name for? So in this case, we were modifying private behavior, which we talked about, like, generally you don't test private behavior, but it's okay to modify private behavior for mocking purposes. But typically what you test, and you notice that when we were testing, we weren't testing the invoke rest method inside the get IP address. We were testing get IP address. We want it to work as we expect. So in this case, we're basically not testing anything because there's no module logic that's happening. We're just replacing the command. But if the command just exists in general, like in your scope, you don't need that dash module name thing. And if you're testing your modules like public functions, like let's say it's a function that doesn't have to reach out to you. Like let's say it's a simple like Fahrenheit to Celsius converter. You can mock the Fahrenheit. You don't need to mock the Fahrenheit to Celsius converter, but you could. I don't even know where I'm going with this because that doesn't make sense as a test either. Yeah, so I mean, honestly, like the module name mode, if you're writing, I know where I was going. So where it can be helpful is like if you're testing scripts, if you're not writing modules, but you're writing scripts, then the mock you can use to mock like whatever commands your script use. So you can mock get AZ account, but you don't have to specify the dash module name. In this case, we were testing a module because I was writing as a module. Like, let's say we were writing a script, and the script's job was get AZVM, test that the name is this, and if the name is, remove it. So let's say we wanted to test that, but we don't actually want to go out and grab a VM and delete it. We could mock get AZVM or not. Maybe we want that part to be live, but we don't want the remove part to be. So we can mock get AZVM and have it return an object that looks like what it would be expecting as an Azure VM object. Let our script go ahead and modify it. And then when our script gets to remove VM, we've mocked that too, and saying when it goes to remove it, don't actually remove it, but return the same result that the command would have actually returned. And so that way to our command, it did everything that it was supposed to, and it hits the happy path. And then we can test things like, oh, we want some input validation, so if the name doesn't match a certain thing, don't remove it. And so now we can set up tests where we say, we can test if it matches this name, remove it, and our test is like, it should work, and this command should return no issue. And like, if it doesn't, this command should throw an issue, there being a problem. In fact, we should probably demo should throw as well as a way to test that your command throws errors okay.
Yep, let's do that. But first run this.
Oh yes, we should probably make sure it actually works.
Oh.
So again, there's that mock happening again.
I'm just gonna continue.
We didn't have any breakpoints at the second but it passed all tests. I guess we should probably do output detailed so to be clear. So by default, Pester summarizes on the tests. This kind of seems counterintuitive until you have like 6,000 tests, and then this is really nice because you don't want to see the wall of stuff coming by. But most of the time, like you'll probably want to modify this to use the verbose output so you can see that the individual tests work, as well as get your nice timings to make sure that your command's actually like performing quickly enough. So. And these two timings, real quick, is like, this was the time to set up the test. This is all the before all and everything. And so that's what happens in mock. And this is the time your test actually took in the it block.
What did you guys do to get into the interactive debugging again? I know you mentioned that.
Yeah, so the long and short will be is that, can you hit the drop down up there at run and debug? This is turning into the optimized VS Code presentation really quickly. The drop down next to it. So in that drop down, hit the PowerShell one. Go down, the PowerShell ... The second from the bottom, yeah.
Yep.
So if you click that, it'll come up with a bunch of defaults. You can thank me for that. I wrote that. So,
Thank you.
yeah. So you have a lot of different options. So these are basically in PowerShell, in all of VS Code, the way you debug this stuff is with things called launch configurations. These get put in a little JSON thing. These will basically come up with some default ones for you. And so I wrote a bunch of these, and I added like those binary module ones. If you want to get really fancy, I added those. But basically, interactive session is that one. So basically what that is, if you run a debug session and you don't specify a script, then what that does, it tells the PowerShell editor services, it tells it to just run for the session. Basically, just sit there and run until you see a breakpoint happen. It's sort of the equivalent of like, if you've ever done like error action preference debug, where like you do that, and then if you hit an error at that point, like go into debugging. It's kind of like that, only it's just watching it for like when a breakpoint happens. And what it's actually closer to if at the command line you did like set breakpoint, and then you just ran a script and then it hits that. When you do that, that's literally what's happening, is like in the background it's going through it. In fact, let's do this to prove that. We're getting way off topic, I know. But well, take my word for it. That's where it is. Yeah, I love going into the inner workings because I wrote that stuff. But yeah, so that's where it is. So you can get to it very quickly that way. And watch my optimized thing for better ways to do it too. So.
And they're gone. So we're going to create a test that should not throw. There we go.
So as an aside while he's writing this, one of my favorite things I ever do when I write these tests is like when I write my code, if I come into place, because in PowerShell, like there's a lot of situations where like there should never be a null there, but I have no way of testing it. Like I can't have the compiler ensure it like I can with like C# and TypeScript. So a lot of my testing, like stuff will come back, and like I know like there should be no world where that comes back. And so typically what I'll do is like, if not this, then I'll say throw, this thing is missing, this should never happen, report this as a bug. And the number of times I trigger a test on stuff that says this should never happen, that's how terrible of a developer I am. I'm like, this should never happen. Sure enough, I figure out a way to make it happen. A null shows up, I changed something wrong. But again, that's defensive programming. Otherwise, that program just would have continued as on, and I would have gotten error like 15 lines down. That doesn't make any sense. and it's going to take me an hour to track back where that problem was versus just immediately getting a message like this should not be null and it was null.
What? Yeah.
But yeah, you got to. Yeah, okay. And I'm glad Jaap made this mistake because this is a very important. This thing trips a lot of people up. So when you're doing the throw thing, I haven't even read what you did here. Okay. Yeah. No. Oh my God. You know what? My partner, like, whenever she has a computer problem, she's always amazed that, like, she hates, like, how come when you're just standing here, it just works? You know, like, has anybody ever had that here? Like, you know, like, they're like, I've been working on this forever. You just come over and stand there and it just works. I finally figured out why that is. It's because when I come over and I stand there, I'll have her do it over the internet. I notice, like, she just ramrod, click, 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 like that. But when I'm watching, she'll go slower. And then when she goes slower, it works because she's being more deliberate. So slow down. No. So the throw hello, that has to be in a script block. You need braces around throw hello. So take that sub-expression off.
Mm-hmm.
By the way, everybody, please, like, Jaap's in the. I'm really glad Jaap's in this position because, like, when you're up here, like, it's like there's this card game called Anomia. Does anyone ever played Anomia? Are you familiar with this? Basically, it's a card game where, like, you and a bunch of people, like, you just have to flip things down, and a lot of times it'll be like you just have to say, like, it's the color purple, and you have to say, like, purple. But when you're under the gun and, like, the stakes are high, you'll do it, and your brain will just freeze. And it's like the perfect example. Like, when you're up here, like, live coding, like, it's just like you'll do the simplest silly things. So yeah, there you go. That's perfect. So what happens is, like, when you're doing these kind of tests, the reason you have to put that in a script block is because if it's not in a script block, this is like another one of those discovery phase things. If it's not in the script block like that, it will exit out before it gets to the point of the should. Because again, this is still just following PowerShell rules. Pester very much has a sort of like Neo in the Matrix kind of a deal. It's like, yeah, it can do a lot of extra stuff, but it's still bound by the rules of the Matrix. It's still bound by the rules of PowerShell. So if you throw a terminating exception, this it block stops right there. So the way PowerShell gets around that is if you put it in a script block definition just simply says, this is a piece of code that we will execute eventually. And so then by passing that to should now knows that it can now execute in a safe try catch, and then if it fails, then should can do all of its magic to express the right message. But that's why you need, like, a lot of times, like, people just say, don't forget to put braces here, but nobody knows why. So I just explained to you why that is. And let's do a throw message in there. Just, throw oopsies, and throw in a couple emojis just for fun. Very important. There's Windows period. Remember, magic. If you learn nothing else, you've learned that the period key is great for GitHub and emojis. I don't think you put an animated GIF in there. That would be amazing.
I think that's the next step.
Andy and I will work on that. We'll put that into the roadmap for the extension.
Can I ask a question about braces?
Yeah.
Line 25 ends with a brace. Must that brace be at the end of line 25, or can those things be at the first of line 26? I see myself out.
Do you want to start a riot? Like we try to be a non-violent group, and you're just in here. Are you from QAnon? What's going on here? So the question was, as far as the brace. So first of all, to answer the question, like, as far as braces, can the brace be on the same line or a new one? The answer is yes. And the answer is technically correct. Yes, you can do that. Should you do that? I'm going to be magnanimous. It's whatever, we're getting into coding styles thing. So it depends on whatever your coding styles are that you all agree to for a project. If you want to do it on a new line and you want to be wrong, go right ahead. I mean, some people are used to C#. That's how it's done in C#. It's just the convention C#. It's not right or wrong. In C# you can put on the same line and it works just fine. That's one of the magic. Like, we can all have our own preferences and wants, no matter how wrong they may be. Yeah.
Actually, I believe Pester.
Hey, you forgot to push your glasses when you said actually.
Actually, will throw an error if you have to throw the brace on the next line and try and run.
If you're not escaping the line break yet, because it's being passed as an argument to the it.
Oh, that's a good point. I forgot about that. All right. Oh, man. Yeah, 3 cheers for the... all right, so start over. So it turns out that Cunningham's law has proven itself again. Cunningham's law is that if you wanted the correct answer to a problem that you're having, do not post the question, post the wrong answer, and then somebody will be along to correct you shortly. So I have been corrected, yes. So at least in this turn, actually, so in this case, because again, with Pester is Neo in the Matrix, like it follows the rules of PowerShell still. So it is still technically a function.
Look at that error.
Yeah.
Did you put the opening curly brace on that next line?
You know why this is here? This is here because 10 years ago, Jaap did the exact same thing, and he troubleshooted for like 6 hours, I don't know, but like probably, he troubleshooted for like 6 hours, found it, stuck his head in his hands, he's like, I will make sure this happens to nobody ever again. Yeah, he's really good about that kind of stuff. So, yeah, so the reason being is because it's a function, just like any other function, the script block, if you do a dash there, like this is just, because we're using a DSL, everything's shorthand, but this is just a function, like the name there, that's a parameter. The script block is a parameter. If you do a dash, see, there's parameters there. So you can do dash name should not throw dash test in the script block. We're just doing it all in shorthand, but there's no magic here. It's just a function. You could write this, as we said, like it's just a function. So as a result, it has to follow those rules. Now there's an easy way to fix this if you want it, and everybody's gonna love this. Can anybody guess what I'm about to do? Yeah. Yeah. That's the one true way you write tests right there.
Pretty sure that's a violation.
You got everybody to agree on at least one coding style.
You know what? I'm here to bring everybody together, okay? Like, kumbaya, we're gonna sing. Okay, so our test runs. So here's another example where the it and the should not comes in handy, because otherwise you just get those exceptions. But here you can actually test. You expected no exception, but you get an exception, and not only that, it tells you what the exception was. So again, that's why I wanted to add in that little piece there. If we were to do this as like a typed exception, it would explain that it was like that typed exception. And this is nice in the command line, but again, like this seems kind of like, oh, quaint, but I got the code right there. But when you get to the point that you have hundreds of tests and you're looking at like the output in your GitHub action, you're doing a pull request, your pull request is failing. In your GitHub action, rather than have to like scroll through and find the code, to have the test say, I was expecting this, but it was this, and it happened here in the code, that's all super nice. Like you can take this for granted, and you can thank Jaap and the whole Pester team. It's not just Jaap. There's lots of unnamed people who do a wonderful job here. It's just Jaap's the cutest, and so he's the one who we like to talk about the most. But this is super useful for like just finding like where that thing fell, as opposed to, and this is one of those things like I tend to like almost use like a rule of 3 thing here, although I violate it all the time. Like if I'm testing something in the command line, running the command over and over again, if I do it like more than 3 times, I'm like, all right, I'm gonna take the time to make it a test so that I can just run it in the test thing. But then also it will run every time, I'm testing it from then on, so that 5 years down the line, I change something and I can't remember why I did it that way, and then suddenly this esoteric test breaks, saves you from a regression, saves you from a production outage. There's really lots of good reasons. Like a lot of people are like, why do I waste my time with tests? And for me, like, testing the thing that it works just in the moment, that really doesn't matter in my opinion, because you just did it. You just did it at the command line. You just made sure it worked. Other than like for the business contract also, for showing somebody, here's the test that we've written and here they are passing. Like, this is why it's so important with pull requests and stuff. It's like when something changes, to make sure that what we've already done doesn't break. And also when you come back to something, when you need to refactor, or even better, if somebody else comes along after you and they need to refactor, they can at least have some confidence that when they change something, that they didn't break something way over here and have to troubleshoot it without the code base knowledge that you had when you wrote it. And if you don't have that, if you come into an existing code base, an existing archaic script that does some sort of update of a group policy somewhere that somebody wrote 8 years ago and didn't know how it worked, and you need to add something to that, one of the best first things you can do is write tests for how it works today. And then you can go through and change it and make sure that that same behavior that you want it to do continues. I feel like that's the undervalued thing when you get involved with testing about the merit of testing, is the merit of testing is not for today. The merit of testing is for future you and the future yous after you. The testing doesn't, like, it feels nice in the moment sometimes, but then eventually it becomes very like boring, like why am I writing all these? But the tests you want to focus on are the ones that explain how your code works, because that's really helpful to the next guy, including yourself when you forget. So yeah.
What if you inherit something that had no tests to begin with, and you want to start writing tests into that structure?
Right.
What would be your general approach?
So that's what I was talking about. So the question is, like, if you inherit something that has no tests exactly, how do you approach that process? Like, where do you start? So for me, it's, and typically in this case, it's not going to be a module. It's going to be a script. Let's be real. Like it's going to be some script that's on some UNC share somewhere, that somebody's doing. Yeah, the amount of grums is like everybody knows what this is about. So, and you look at this thing and it's got PowerShell 1 syntax. It's got backticks up the wazoo, right? Terrible? Nope, yeah, boo, boo. But so and you need to modify that. So the first thing I typically do is my approach is here's the script. How's the script typically used? It's used to update this batch process of this thing. Okay, well the first thing I'm going to do is I'm going to run that script hopefully in some sort of isolated environment. If you're really lucky, there's a test environment. If not, you find some way to build a test environment, modify the script enough so that it can target a test environment. And once you can make that work, then you can write the test to just run the script. Like that test where I mentioned, like describe this, it should work. That's like the first test I write every single time. I just write that and then I write the command that was supposed to do the thing and just make sure that the thing even works at all and doesn't throw an error. Because if it throws an error, it'll fail the test. Once I start there, then the next thing I start doing is then I start mocking out the dependencies in the thing. So if it reaches out to an API or that kind of thing, if I can't build it, have it just target a test environment, then I'm going to start mocking out, okay, this step where it goes to remove, my test now will have a mock to, rather than remove VM, just do that as if it did that thing. And so once I mock all that stuff out, now I have the logic of the script. I can run the script in what I like to call, like dry mode. I can run it without it actually doing anything. It's like building what if into the script without having what if. By the way, that's an aspect, as Jaap was saying, is that it's an opportunity to make your scripts more testable. Like if you have what if built into a script, that makes it really easy to be testable because you can just test against like what the result was without actually doing things. So yeah, I mean, I'm getting off a tangent again. The general framework I do is, if you inherit something, then first, if you can get into a test, if it can be modified or at least somehow like retarget, if it has variables where it can be targeted to a test environment, build that test environment because that's going to be your most obvious way to be able to test it. If you can't do that, then mock what it reaches out to, and then for what those results are, and then define what your new results are for what you're going to change, and then start adding that. A good example here too is like if you're doing a pull request to a repo that doesn't have tests, the very first test can just be a test just for the feature that you're adding. It doesn't have to test the entire environment. And you can take that approach to internal things too. Maybe you don't test the entire script for regressions, but maybe you just test the one new feature that you're doing. You should test the whole thing first so that you know that what you're changing doesn't break something over here. But if you don't have that time, like you can at least, there's always a good reason to at least add a test for existing, not net new things where you're just prototyping and going crazy and throwing stuff away. So that's my take.
Yeah, I've actually been in the situation where it wasn't the script, but it was a module. And we had about 2% test coverage when I inherited it. And also I had no idea what it did. Well, I knew what it did. I knew what the end result was. So I just spent time digging into very, very dirty code. And trying to figure out what the important parts were, what the common structure of that module was, how it called different things. And the moment I identified some of the key parts of that code, I wrote a number of template tests as an example. Wrote a contributing guide for everyone who submitted anything to that repository from that moment on, that they had to use tests, and here are some examples, and here's how you get more codes, because then you get to the point where it's at least not getting worse than it already is with almost no tests. And from that moment on, just add tests until you are at a point where you have coverage and you have your tests available. But it also included actually changing the code, so it became more testable because some of the code was relying on internal PowerShell variables in order to determine if it was macOS and stuff like that. And we just abstracted that away to internal functions that we could then mock, so we could simulate different operating systems as well and see how the logic worked without actually running the tests on different OSs.
Yeah. So we pretty much covered so what you see here, what we've shown here, like these, and especially like should throw as the gotcha that. Like there's lots of additional like esoteric aspects of Pester, lots of things that cover test cases, but ideally, like this, if you understand these concepts, like 90% of my tests pretty much just only use these concepts. If it's more complicated than this, a lot of times you'll actually want to look, is like, am I writing the right kind of test? Is this too big? Is this kind of a thing? Now, sometimes it is justified and it's worth using a lot of the other keywords that exist in Pester. But for the most part, the kind of core of these are where you're going to want to be. And so I'm just going to show one thing here real quick. So you can go to pester.dev, and these are all the docs for Pester. And so everything that we talked about, and you see here like about the assertions, here's all the information about should and how it works. And these docs are pretty good. There's a full command reference for like all the options. But as you can see, there's not a lot here. Like we didn't talk about, oh, am I even showing the right thing? I am showing the right thing. So there's things like before discovery, you know, if you need to do a little tricky things about setup. There's things about reporting, JUnit report, NUnit report, different kinds of ways you can export test results. We're not going to go too much into that, but in the short, like some things like Azure DevOps support really nice like outputs of test information rather than just the XML or the console one, and can also like give you analytics over those. So you can identify like flaky tests and that kind of thing. So that comes way later in like the Pester journey. We're not going to go too much into that, but there's lots of great articles on that kind of a thing, and there's like GitHub Actions for that kind of thing as well. And like when you get to that point, especially when you're really doing like CI and CD, that stuff becomes really essential. Let's see, I don't think there's any real keywords. Pester does have a really fancy configuration syntax that was added in Pester 5 that lets you do all kinds of really neat customization of how it runs, how to specify runs. And in fact, the Pester VS Code extension uses this stuff very heavily. In terms of different types of output, recurse paths. So that whole configuration is something you should know, but for the most part, you don't really need to know it initially, just the invoke Pester type stuff. So yeah, all the documentation is here. It's really good. It's got a lot of quick starts about Pester, covering a lot of the same kind of stuff we talked about here. Much more elegantly written examples than the chicken scratch we just put together today. Like, man, I wish I would have thought of this. See, this is great. See, there's a function, get the planet, given no parameters, it lists all planets, get planet, count should be 8. So rather than like the PowerShell examples, these are great examples of what a test should look like. It's easy to read. It's easy to see. This is kind of an example of a mock or a fake or a fixture. And here we are doing our planets. We make sure our commands all work as they're supposed to. This is a very easy test to read. What it's doing. What the area it's working on, which is this command, and then what the specific thing that it's doing. So moving on from that, then we will go to just back here to our examples. So now that we have this, I'm going to enable the Pester test extension. So this is an extension that I wrote that is out on the marketplace. That what this does is that VS Code has a built-in like test UI framework for testing, and it's designed to be universal so that VS Code has adopted a lot of the great ideas of the PowerShell Sacred Promise in that you learn it once and it's one of the best investments you make in your career. And whether as you move on to things like Linux, Windows, et cetera, you still have like that same core concepts that you work with. And VS Code does such a great job of following those same things. So like the debugging, when you debug in VS Code, if you start moving on to doing like C# or TypeScript in VS Code, it's the same debugger interface, it's the same breakpoints, it's language specific, but it's the same feel and the same, you don't have to move to like a whole different IDE, and so a lot of your concepts transfer, and so you can get ramped up to speed on that so much faster. And one of those things they have for this is also a testing UI, so there's a unified testing API for all the different things you can test, and so I wrote a plugin for that interface, basically, and so that's the Pester test extension. So when you enable this, and when you enable it live, I don't know, make sure this goes. So when you enable this, you'll see that there's this little testing icon that shows up over here. And this stuff is flexible. You can put it wherever you want. If you want to do the secondary sidebar, if you want, we do secondary sidebar. If you want to bring it over here and have a nice little like view of it all the time, you can do that. But this brings basically a whole bunch of stuff. But as you write tests, it has a little watcher. And if I do, here we go, it is a new test. Save, you'll see it automatically discovers that you have a new test available. So all of this is just a front end to what you do with invoke Pester at the command line. It just ties in and gives you a much nicer view and a much easier way to run things. So once you enable it, a few things happen. You'll notice there's these nice little green triangles that start showing up next to your tests. So it auto-detects all the tests that are in your environment and gives you information. So you can left click to run. You can right-click to get more information, like debug. You can find where it is in the test explorer. And here's, again, organized based on your describes and its and the actual files and that kind of thing. And then you also have other things like add a breakpoint for the test, a bunch of things for that. And so you basically just, everything that we've been doing at invoke, the invoke pester command line, like I don't even need that down there anymore. But if you want to see what's going on here on the output pane, you can go down here to the pester, and it'll show up here, and you can see everything that's going on. So you can see it's discovering, it detected that there was a change to this. It found that a test had been moved, and it shows like the test paths. There's that test works that I added, finish discovery, and that's just the info level. So if you do Control-Shift-P, you go set log level, and you take this all the way up to trace. Now it'll get like wild if I make a change here, I think. So now you get a whole bunch of extra crap. So you could actually see the JSON stuff that I do back and forth. You don't need to, I'm only showing, don't worry about understanding any of this. I'm just giving you the idea that if you want to know the guts of what's going on, you can see it. And this drives me crazy, like when extensions, you have no idea what's going on. Yes? When you say the drop down. Oh,
in the terminal it says Pester.
oh, this thing. I'm sorry. So the output pane. So this is just has to do with in VS Code. This is how extensions give you information. So like if you go to Git, you can see when you're doing stuff like with the source control thing, you can see everything in the background that VS Code is doing with Git in terms of like git stack, git info, git status. So yeah, the Pester extension just shows up here. It just shows up automatically in that list once you enable the extension. And actually, technically, the extension is designed in such a way to not be enabled until it sees that Pester tests are available. So you won't see it until you're in a workspace where Pester tests actually exist. Yeah, no, most people don't, and it's because a lot of these outputs are terrible. I mean, I'm not going to argue that like this one's terrible. I've argued like we've been trying to make this one better. But, like you have no idea what's going on here, and like who knows what this bug is? I don't even know what that is. But this is an issue to file with Andy tomorrow live in the presentation, I guess. But yeah, so a lot of times these aren't, and honestly, like seeing these bug me. That's why I worked very hard to make this one like really easy to view. But it also supports this very special log level thing, which is fairly new. Where like if you just want to know what's going on and clear it here, then it's pretty easy to just quickly read what's going on in terms of, and just to make sure that the extension is working the way it's supposed to. We're spending way more time on this output pane than I thought I ever would, but. So I just want to let you know that's there.
Why is there no emojis in there?
Waiting for a pull request.
The question was, even though it was on the mic, I just want to reiterate it for posterity. Why are there no emojis in there? And the answer is they didn't pass the test. No, I don't. I mean, there can't. The funny thing is, oh man, are we going to go on? How much? We got so much time. We're going to go on a tangent. All right, here we go. Here we go. Let's go to module fast. Let's see. Do I have an active GitHub? Okay. First of all, in module fast, every GitHub commit has an emoji in it. And these have special meaning. These affect the release notes. So when you go to the release notes are auto-generated from the emojis. There's this thing called Gitmoji that I have subscribed to as a concept. The idea that, so if you know, man, we are way off the reservation right now. So this is an idea that you can use emojis to summarize like different types of changes that happen in a thing and be able to generate release notes based on those. And I love it. And so I don't do this for any of my professional projects because my coworkers would kill me. But like you can't commit to this repo unless it has the correct emoji in the beginning. Like the GitHub action won't let you. So and if you go to my commit history here, which there's probably a few in there that are overwriting, but for the most part, these have those little icons in there for all the changes that happen for et cetera. See, there's one that didn't because I don't think I had it at the time. But so my point more being is that, and then also if we go to the actions, if it's got the flow here, no, these are the new actions, okay. Press probably has them. Anyhow, I have GitHub actions where the whole flow, they all have emojis in them. So like, look, I subscribe to this subject. When it comes to, outputs for certain peoples, I just try to keep this simple. So I got really defensive there. I just realized it's like, no, I want them to be there.
You could make another log level, right?
Yeah.
Log level emoji. Just saying.
This is revenge. This is revenge for when. This is revenge for when you were behind the keyboard, isn't it? Yeah. This is petty. No. All right. So with the Pester test runner, you have all the things here, and you have the tests over here. So when you want to run your tests, you can run them lots of different ways. You can run them with this, which runs all the tests. You can debug the test, which does the same thing as that interactive. This just fires up the same launch configuration for debug. You can also go to each individual test. You can run a group of tests, or you can run an individual test. So these are brand new tests. And when you run it, again, here in the, aside from the output terminal is now the new test results terminal. And this stuff you can all use to like put wherever you want and that kind of thing. In fact, I wonder if this one works with the new detached editor thing. No, it doesn't. Oh, well, this does. I don't know if you knew, this will be in the presentation tomorrow, but did you know you can do this? This is new as of a couple months ago, and it's awesome. Did you know you can do this? Let's see. Again, turning into my optimized presentation, just, so let's do a PowerShell. You know, you can bring this up here, as long as my debug isn't running. And now you have a PowerShell terminal editor. Did you know you could then do this? And now you have your own VS Code separate editor. And then did you know you could do this? And now you've got it right next to each other. And then did you know you could do this? And I'm gonna stop. If you have multiple monitors, that was it was the #1 most requested feature of VS Code for like 4 years. And the reason they couldn't do it is because it was a fundamental flaw in Electron that they couldn't do, but they finally got it to work, switching some stuff to WebView, and so now that's a thing. So when you go to run tests in the extension, this is just running invoke Pester in the background. In fact, if you look here in the test results, you'll see this is the exact same output as we were seeing on the terminal, but it's running it in a special background PowerShell instance. And so every time you run a test, it takes all those test results that show here and gives you them here in a summary. So you can see the test. You can see in these cases, you know, there was no output for these, so they passed. This one, you get that should result here. And you can actually take this, and then if you go to the source of the test, when the test fails, it's not as obvious here because, so the problem here is like we're doing the light theme here. Typically this has like a different highlighting, but it automatically takes, if one of your tests fails, it gives you the message here so that you can see in line as you write the tests, if your tests fail, why they failed, without you even having to go down to the command line. If you click it, it'll show you even more detail. And it's really good about, some of them like these throws, it can't really do very well. But if I change this to 55 on that test and I run it, now it'll fail, and notice it'll give you the information about what it expected, but what it should have been. And you can hop between your different versions. They should show up down here in the problems. So you have this really nice, just integrated experience with the VS Code editor of doing Pester, but without having to go to the command line, check them. And another thing that you can do here is that you can, there's a little watch option. So this is fairly new. So you can turn on continuous run for a test. Like for instance, should not throw. Okay, you turn that on. And now with our test, we can go through here to fix it. And as soon as I hit save, it will rerun the test. And so you can keep, you know, do that. It's not going to work because now, you know, it was expecting apples, but it doesn't quite match. You know, I can do apples star, save, and now it works. Take it off, save. Now it doesn't work. So that's a really easy way to really shorten your developer loop. And you can have it, we can just watch that one thing, or you can watch your entire test suite. So I can hit save, and it'll run the entire test suite over and over each time. So depending on how fast your tests are and such, my whole goal with this was to kind of shift left, move your developer loop so that when you're doing things and you're testing them, you can work faster and you can be more productive. So you can work that one test over and over until it's good. Yes?
Pester one support, and is it a good idea if it does, the idea of writing your test to use something like run spaces or parallel jobs?
Yes, it does support it. No, that's a terrible idea most of the time. I mean, so, and it's not, so, I'm being a little facetious. So the question was that if your tests are slow, is it worth writing them in parallel? And so the short answer is yes, it is possible. But it's not really supported within the framework. And the main reason being is because the main Pester, the way that it controls, starts in a particular run space. So in order for it to coordinate all the mocking and stuff to do that into other run spaces is very difficult. So that basically that part kind of sort of exists, but it's very difficult to work with. If the test fails, reporting the information back, it's very difficult for Pester to handle. That being said, the content of a test, if you have a test that says these 56 variations work, and then the content of your test you want to do a for each parallel, that's totally fine. That will work. The problem is that now in your tests, you're introducing potential race conditions, potential all that stuff, and you're going to spend more time troubleshooting your tests than you are troubleshooting your code. So if you're going to do that fancy stuff, it's generally better to just keep it in your code, but your test, again, that to me, like parallel tests kind of violate the DAMP principle in terms of descriptive and meaningful phrases, in that your tests are no longer as obvious if you have like a run space thing. It's not as easy to get in there and debug. To me, tests should sacrifice being cool and clever for being descriptive and meaningful. Like tests should look dumb. They should look like they're quote unquote bad code, as long as they're very clear what they're doing and are very simple to work with. Because when you want to debug that, what happens when test 36 fails? How do you debug and hit that breakpoint if you don't know how to do enter run space debug and do any of that kind of stuff? Is it really that bad to just like let that in parallel? So typically the way you solve those things, and I'll show with module fast, is that's where mocking and stuff comes in. If you have something that takes 50 minutes to run, but the thing you're testing is just the output validation, why don't you just mock that part? And then later on, like, this is the whole thing of staging tests. And that's, you have the ability with the extension to take tests and go ahead and mark them as included or excluded. In fact, you can filter here, and you can add tags to tests, which we didn't really cover tags, but that's a thing. But you can say, just returns.
Okay. Can I add one thing to this? If your test suite is big enough, and let's just give an example, one part hits the file system, the other one is testing some database components, and the other one is testing if the documentation exists and is up to whatever spec. If you're doing it in a CI/CD pipeline, you can just split it up in different tasks and split it up that way instead of bothering with run spaces and PowerShell jobs. That's one way that I split it up in the past.
So if you're not familiar with Module Fast is a module that I wrote that is designed, I don't even know if I have it here at this level, but we'll do it the fast way. If you don't have Module Fast, you can just do bit.ly. If I can type. So do that. Now you have Module Fast. Hey, it's a GIST. Like, unless somebody compromises my account, this is perfectly fine. And don't let purists tell you otherwise. So Module Fast is just simply a way, like, if you want to install a module, like install-module fast. I'm not going to do it here, but AZ. Typically, this step takes forever on a computer. You notice it calculate all 172 dependencies to install the Azure module, every single thing in that. And if I were to run this, it would install it on parallel and do it. I had to build an Azure like D32 VM to bottleneck this thing, because like it pulls everything from the Azure CDN, decompresses it on the fly into your file system. It can install all of this in 8 seconds. When it takes about 15 minutes with just install module or install PS resource. So yeah, this is just my way of, and it's got all kinds of declarative stuff. We're not talking about module fast. I mean, come on guys, stop with the module fast. Stop with the module fast questions. I know it's cool, I understand, but we've got to talk about Pester, okay? But with this is that because this is very complicated, and because of the way that I wrote it, is I wanted it to, as much as possible, be PowerShell based. And because of the nature of it, it kind of needs to be in one file. So this module fast is about 2,165 lines long. And because it's got all kinds of things from the evaluations to the processing to the way that it handles these things to the conversions, the authentication header values, how it, just trying to find a local module is all of this crap, But so as a result, like this is a very difficult thing. It does a lot of things, and so it needs like a good testing surface. And so for the tests for this, I have pretty extensive tests. So first I have a lot of different mocks. So these are ways to like set up examples where I want to test something, but I don't actually want to reach out to the PowerShell gallery. And I also want to be able to test it offline in case I don't have internet access. So here's like a few examples of like, I want you to be able to define a manifest where you can say what modules you want to install and have it just figure that out. I want it to be able to, if you have a script that has a requires line, I want you to be able to just point install module fast to that script with the requires line and have it install the modules that are part of that script without you having to do anything. And it does that. Here's a script you can do with a module, you can do with a script. These are all the things it does. But I need to test for all these cases. So if I change something in one of them, because they're all kind of similar, because a lot of these things are sort of like different ways, but then they all funnel into the same logic at a certain point. So if I change one thing in here, I need to make sure all these things at work are still compatible with how my logic changed. And because I'm not using C# or something like that, there's a lot of type safety that there's some of that stuff that I can do in PowerShell, but most of it I don't find out about till runtime. So the best way to find those runtime tests is to actually run it through Pester to see if it works or not. So if I go over here to these tests here, under the module fast tests, we have all of our tests, and you'll notice they coincide with the outline, and if I go to the test, they're all reflected here. So some of the first tests that I do are some sort of basic constructor items. And you'll see these tests again. Here I am. I have this very special class. It's a big, ugly PowerShell class called module fast spec, which is what defines a module. And so I'm testing this class to say, hey, when I make this thing, I want to be able for each of these properties. When I make this thing, I want to test for each of these properties that it exists and it should contain that. For this name, you know, like I want to make sure it is this. I want to make sure that it's this. I want to make sure that that's null. I want to make sure that that's null. I want to make sure that that's null. Here's an example in my case. Like I'm testing one atomic thing that when I give it a name, all these other properties are okay, but I have multiple shoulds. So like that's an example like an atomic test. And you'll see, I'll go ahead and just run this whole test suite at once. And it also should work in real time. So as the testing is running, in real time over there, it shows as Pester is going through the tests. This is the part that was the hardest to write. So in real time, you get to watch your test run and how they're doing on timing and such. And this one failed because this is on purpose an ugly test because when the number of AZ modules, this is actually a bad test because when the number of AZ modules changes, this test fails. So since the last time I ran this test, they've probably added some new API thing. And I just go in and I update this test every time because I'm too lazy to write a different one. But because this is an end-to-end test that I kind of need, but it's really hard to write it otherwise, that I have a note to myself when this one fails, just go and update this number from 86 to 88, for instance. But
What's the purpose of having it check the number of...
Well, that's a good question. Shall we read the test together?
So the question, what is the purpose of the test?
The question is, what is the purpose of this test? What do you think the purpose of this test is? Read it. What does it say?
Also, yeah, it gets a module with lots of dependencies and it should be 86, but why does the number matter? If it's 87, why is that bad?
Because, so the question is that in this particular test that I wrote, and we're getting like, you know, this is getting a criticism of my code, which makes me really insecure. The question is like when we do this, when we get module, I wrote this test as gets module of lots of dependencies. And the point of this test was like get the module and then it should have count 86. This is a perfect example of one of those things I was running at the command line over and over again. Because the key thing was not just simply that it gets the modules, but it gets the right amount of modules. So at the time that I wrote this, I wanted to verify that when it gets it, it wasn't missing any modules. I wanted to make sure that it was getting all the modules in AZ. The thing is that, so the proper way probably to rewrite this, and it was pinned to module version 11, I probably should have pinned it to a much tighter module version. I probably should have pinned it like 11.0.1 so that this test would work every time. So since then, there's probably like module version 11.0.2, which even though they say they don't do breaking changes or new feature updates, it's the AZ team. They do that stuff all the time. So, so that's why this test broke. And so, but this is an example like, okay, I have a bad test here. Fixing this would be probably making that more specific so that whatever it's querying, the inputs will match the outputs every time, if that makes sense. Kind of, yeah. I mean, like in this particular case, and I also used it for timing. Like, again, when I run this test, let's see what we can, because we have our fancy thing, we can go here, reveal in Test Explorer, there it is. And so a big thing that I have all these tests is like, I was really optimizing for performance. So like I wanted to make sure when I ran this like 2.5 seconds, you know, this probably started at 8 seconds and I changed some stuff. All right, great, now it's down to 4 seconds. Changed stuff. All right, now it's down to 2.5 without me having to run it manually every time. And the entire history of this whole run thing shows up in the test results. So at this test run, I can see the tests that fail go up to the top, but I have a whole history of what my test runs were, and I can go back and you can even run like analytics on this to get like, look for flaky tests. Tests that sometimes succeed, sometimes don't.
Would it be fair to make the argument that test
including the corrections you suggested, be rephrased as gets the right number of dependencies for a module?
Gets all the dependencies. Yes, it could. So how about this? How about we just pretend that test doesn't exist? Because yes, I know it's a bad test. We get it. I know this is pick on Justin day. I got it, all right? File a pull request and fix it for me. I ain't got time for this.
In the defense of the audience, you were the one to show this test.
Yes, I was. It was the one test that failed. I'm like, all right, I got to show the failure behavior. But look how nice that interface is. Look, expected a collection, actual, like it's in separate tabs. Like you won't believe the parsing I had to do to make that work. Like it's, yeah.
You might want to check the general Slack right now.
I know, right? Just admire the aesthetics of it. You know, don't worry about the functionality. Yeah.
So not about this specifically. This is a big
Yeah.
test. Okay, so you're running your test and you say like, hey, I want to go out and grab a module has a ton of dependencies. Where's that threshold for code smell? Like, okay, well I can write a function that'll go out and check some other method to see how many dependencies that module has and grab that number and then compare it against what I actually got. Like, where's the code smell for writing more code to make your test work versus just saying, I'm just going to go in and update that number.
I mean, that depends for each, like, so again, like I say I update this number, but originally like this, I shouldn't need to update this number because I should just make this is a test that I should fix because the module version should be more specific. Again, it really depends on what your threshold is. Like if this was mission, you know, this is just a side project. Like, you know, I mean, like it is like, the pull requests that go to it, like, you know, is like, I don't push until I verify all this kind of stuff, et cetera. Like, but if these codes were like gatekeeping to like a CD push, then this is not acceptable, you know? So like an example of this test is like, if I wanted to test this really quick for the logic, I would just take a quick snapshot of the AZ modules and mock it out and save it. I would convert to JSON, save it, and then do a mock here for when it calls get module fast plan with these parameters, automatically return this result. You know, and then make sure that that count matches, just to make sure that my code isn't accidentally filtering something it's not supposed to. But in this case, like I wanted the live data from it each time it runs, so that if something changes like that, or if I change something, I want to make sure it works against the actual code. So this is more of an end-to-end test, and I think it's actually in the end-to-end section. So as to like, the question was like, how do you know when to like fix a test versus just kind of leave it flaky like that? I mean, it just depends on your culture, the importance of the thing.
More specifically, when should you just walk something and say that's going to be good enough versus no, I really need to go out and check this against live data to make sure it works.
Yeah, I mean, honestly, it depends on the team. I can't answer that question. It just depends on your, you know, I don't know. When do you use the curly brace on the end of the line versus the new line? Like, I mean, yeah, you want the engineer's answer? I'm going to give you the engineer's answer. It depends, you know.
Other than the mock API call could be to just be friendly to the API. It's not something you own, so you don't want to like spam somebody else.
Yeah, yeah. Every time you do a save, yeah, like that's a good reason. So, all right, let's get to the tests that are very similar to like what we were talking about earlier, which is I should have these. So parameter binding. This is a common one that you might actually do pretty commonly. Let's go to where it is in the thing. So here's an example. Like so, and this is an example of something that we didn't really go into, which is test cases / for each. And this is a case where this is the old Pester for syntax. It's now technically like you're supposed to use for each, but they're aliases to each other. I just really like test cases versus for each because it very explicitly calls out in a way. And this is an example of doing what are called data-driven tests. So if I go here, I define a whole bunch of different tests, which are the name. You know, when I get this name, the module version should be that. When I get this, it should be that. And this is an example of all those things. And I want to test them in all kinds of different variations. So that's where I do this. And so when you do the test cases with these, if there's a name here, that test matches this. So when it generates the tests, you'll notice the test names are all dynamically generated from that. So that's a nice way, like if you have a bunch of variations, this is a way to be dry, but still be reasonably damp in terms of what the process is doing in terms of the tests. So it gets the module with the parameter. When I run this, you know, the actual result, it should only return one item in the plan. The module that comes back should be the actual result that I want to match that specification. And here's the thing, like I want to make sure that it's actually a NuGet version and that it's not missing. And this is the thing where like some of these tests have to have little special checks. So I just added a simple little section here where I can have a little custom check if I need it for that particular test. So if I define it here, great. If not, don't do it. And so this basically generates out these tests and runs them in that way. But this way I can still breakpoint them. If I like, for instance, debug this test, I can come to this breakpoint and I have all my information. And if you have the Tyler's great inline variables extension, you can see the information of where it was at that time. So this test, 4 AZ accounts of the spec. I get AZ accounts, I get a version, and I'm able to check all that. And I can come down here further, and I don't know why I'm looking at that screen. It's right in front of me.
Is that Pester specific where you have the test and the carrot, so it's actually being replaced?
That's Pester specific, yes. So these are what are called data-driven tests, and we might have some time to go through them. I think it's in here under should. But yeah, basically there's a way to write tests where you can have a for each of objects. So you can define them in a list and do it that way. Let's see, where's do I have the giraffe one? Actually, if we want to get really meta with it, you can go into the Pester test for the Pester test extension if you want to see those. And those have emojis galore.
What's that called though?
They're typically called data-driven tests, and Pester are called test cases or for each. So if you go to the Pester dev help, if you search for each, it'll probably show up here.
Scroll up in the left panel.
Is it up there and I just missed it?
It's under usage. This very top, usage.
Oh, here we go, yeah. Data-driven tests, so yeah. So this explains like that whole process, and you can use a hash table, and they even use the cactuses and the camels, and so it'll show an example of like when you run that, like that's what the result is. And so it just shows an example of being able to do data-driven tests. So it's just a way to don't repeat yourself, so you don't have to write out all that test, and more importantly, like if you need to fix the test, do something else, you don't have to change it in 15 different places. Like the core logic of the test is the same, but you're just testing various inputs and outputs against that. And so another example I have of that is in here is, where's my tests view? So this is a good one. So Module Fast supports this really nice shorthand syntax. So if you wanna, like when you do, if you do like install PS resource, that kind of thing, if you wanna pick a specific version, you have to do that stupid like hash table syntax where you gotta say module name equals this, required version equals that. Like I just didn't find it very ergonomic. So in my version, I made it so there's a really nice, easy shorthand syntax. So you can do like equals, you can do greater than, you can do colon for that. And so this is an example where I have all these different examples of those kinds of tests, of different ways you can specify it. And then the actual individual test, if I go to it here, this is the one test for all of these tests. And I just defined a bunch of different test cases that just goes through this same process each time. Does that make sense? Yes? No? Yeah? Okay. So what that allows me to do, and again, I can just breakpoint here and I can run my debug, and I have all these different individual ones I can run and say debug test because they all get tied to that same one. And you can see down here, the icons down here tying over here, although I think one of my test runs got stuck, so I might have to restart my test. Okay, and if for whatever reason this thing ever gets stuck, this is the reset button. You click this and it'll rebounce the entire extension, restart the Pester thing, and get you going again without you having to reload the entire Pester test window, so, which you might still have to do because my thing might be broken because it breaks a lot. Huh? Look at the smart guy over here. So random guy who's a beginner at this, even he realized that the debugging was still running and I was still paused in my last test, and so that's why it was stuck. So there we go. We'll run again here. And we get to our actual here. And so here's an example. So there's the spec. And the spec was just simply, this is just an example of doing get module fast plan AZ accounts, which I'll do here like for real. I do get module fast plan AZ.accounts. In that time, by the way, if I do the verbose debug, a bunch of calls actually happen, but I do a bunch of stuff on the back end. But it does a lot of caching and stuff. So in that time, it verified that module, if I wanted to install it, this is the version to install. If I do AZ, it'll evaluate that. And it's much faster the second time, do a bunch of caching. So these are like the commands I'm testing. I'm just testing like, what if I want to do az.websites? What if I want to do AZ websites less than 3? So now notice that it's the most recent version that's under 3. AZ websites less than 2. And you can do all the NuGet syntax and all that kind of stuff. But these are just examples of like use cases that I need to test. I need to make sure when I run this, that's not going to throw an exception, that even worse, it's just going to return nothing and confuse the user. So for each one of these kind of ways that I do this, I have all these different ways of evaluating things. And if you want pre-releases, all you got to do is add a bang in there as opposed to -allow pre-release. But the nice thing about this is you can specify some modules to be pre-released and some modules not to be pre-released, which you can't do in install module or install PS resource without doing multiple different commands. And as you can see here, like everything that I wanted a user to do, I have defined as tests. And so if I go back here, so this is like when I get the module, like these parameters all work. When I get a module with these strings, every one of these string things work. With certain combinations, like module fast is very PowerShell in that you can pipe stuff to it and it'll work. You can pipe, if you do get module, you can pipe that to update module, even though like the stuff that comes from get module is not part of my module. I have an adapter that will detect that you fed it the old modules and it'll assume you want the latest versions of those and still work. And if you want to see some really ugly PowerShell class work that absolutely probably should have been written in C#, you can look at this. That's the Bootstrap script. Let's see, where's the module fast? Let's see, Control go to, that's all I want. What's the, oh, it's killing me, Control Shift O, that's right. Module fast spec. If you don't know, in the outline over here, it'll outline all your objects and your functions, that kind of stuff. And Control Shift O lets you go anywhere in your module as like a real fast way, regardless of what file it's in. So this module fast spec class, like if you want to see some ugly stuff, do not do this. Like if you don't have a reason to, like I made my own custom getters. I did like look at this stuff. It's like this is an example of like something that you would come alongside and like, who wrote this? Like what crazy person? Like this is unintelligible. What is going? Like he wrote his own module fast comparer that matches up with the C# interface. Like who does this kind of a thing? What are they thinking? And they got all kinds of comments about like, don't do this. This is a hack because I don't know what I'm doing. Here's the Stack Overflow that is like, this is my, oh, I don't have to do tree installed, but yeah, if you want to find, let's see, fix me. Yeah, so fix me, fix that, fix this. What are you doing? This should totally be wrong. This is not surfaced right. So like, again, this is how you write code. It's just the way it is. But at least I made it clear. Like this, the hack ones are pretty good. I bet I got a few good ones in here. We need that to be a task. NuGet doesn't, this is one of my favorites. NuGet doesn't convert major build versions correctly. Like it's ridiculous. I have no idea how long that took me to figure out. Anyhow, but see, again, there's all this weird esoteric behavior that I've found like obscure articles on, but because I've written tests for them, I know that like I'm going to account for that weird behavior if I change something. So, as I add things and such, I know if that test fails, I'm like, oh, something in that is related and it got tied to that particular test that I wrote. So I have this big crazy class, but because I have these really good tests that cover the aspects of how that class works, how its constructors work, how its methods work, how when it's created, does all the aspects of the object work correctly, that even though it's kind of crazy and Byzantine, I can at least be pretty well assured that if I need to change something, I need to use that object, my test still pass, I can still be reasonably assured that like nothing's gonna break. And so far, I've had a pretty good track record with Module Fast that with the new releases that I've done, I haven't really had any breaking changes. Like if you go to Module Fast right now, everything in my issue list pretty much is just enhancements. And this one is like something that's like not specifically related. But most of the bugs that come up have been sort of like ones that were kind of fairly in the past before it, or they were certain things that different environments that I hadn't accounted for yet, like testing this in GitHub Actions. Oh, there was a little thing that I missed that GitHub Actions does, so I added that as a fix. But I made sure that that fix doesn't break things somewhere else. So we have a whole different way of looking at our modules and our infrastructure so that when you implement tests, especially when you're doing things that are really esoteric like this, you can feel really confident that more importantly, as you change things or as you add new features, that you're not regressing and breaking other things. As well as having, if somebody came along, God forbid, and wanted to help maintain Module Fast, like, hey, I want to contribute to Module Fast. The first thing I'd say is, go to my tests. My tests will show you how I intend Module Fast to work. Because all these tests, these don't test the internals of Module Fast. They don't test my little helper functions that are inside. They only pretty much test the external surface. They test, does Git Module Fast plan work the way it's supposed to? When I install a module, I'm using splatting here because I'm a good child. And when my installed versions get the modules, limit them, does it get the right ones? The installed versions, we should have 2 versions. And of those installed versions, one of them should be 2.7.4. This is just, my tests explain like the thinking behind what my code actually does. And that way the code doesn't really have to contain it as much, or the why. It still has those, but mostly what's in the code are comments that are like exceptions, like this is weird because, like, yeah, I know that there's an easy way to do this, but it turns out it doesn't work, and here's the Stack Overflow that explains why it doesn't work that way. Like that's like my general process, yeah.
Can I ask you to go back to the test with the test cases?
Okay. So the string parameter one here. So just go to test, okay? So this is the test, or these are the test cases, excuse me.
And just scroll up just a little bit, and for the sake of the rest of the audience, talk about the variable expansion that's going on in the name of the it.
So this little brace part here. So the question is like, just for this, how this variable expansion thing works. And rather than in the context of this, because it's a little confusing, I'm going to go back to this help for the data-driven tests. And so here with the using for each and test cases with a hash table. So the most common usage of data-driven tests is find multiple, actually, you know what? Jaap, why don't you explain this? What? I know you were getting comfortable.
No, I was very comfortable.
Actually, no, actually, come here. Actually, even better here. I can explain it this way. You know, make it.
Where's the replace thing?
In the TOC, there's one saying using templates.
Expected name.
What? Spec. Yeah, there. So does it replace?
It does replace. I mean, yeah. Short being is that so this is a way of writing tests where you write the way your test is once, but then you want to supply different data to it each time. You know, the equivalent of this would be writing the same test, but saying get emoji dash name cactus pipe should be whatever that emoji is. You know, and then you write another test that is get emoji dash name giraffe should be this. You know, you have 50 test cases, that gets really redundant, really old, really quick. And if you ever have to change that, you could risk a find replace and worry breaking another test. Like it just gets ugly. So like, why do that when you could just write the logic of the test once and have those inputs and outputs be different each time? So that's what a data-driven test is. The test is driven by the data. Like it's amazing that, so intuitive. Who thought to put it that way? And so what you do is you define a hash table, which is just, you know, it just has two properties. And the properties are name and expected. And what you're allowed to do there is once you define that, and the hash table can have anything. It can be name, it can be, you know, cookie, it can be whatever you want. They can even be emojis if you want to, if you really want to get crazy. Don't do that. And so all you got to do is that bracket. That bracket is just special syntax. It tells Pester when in the discovery phase, when you find this test, if you see brackets in the name, then go into the test body, run that evaluation from the hash table from what's in the for each, and then replace what's in the brackets with whatever the value of name is for each test case, and generate tests for each of those. So, yeah, so if you remember earlier I said for each and test cases, so we see where it says dash test cases. Picture that dot if you right-click that module spec test cases and then do go to definition. Yeah, sorry, so you can make again, it's a hash table. Again, Neo, matrix, follows all the same rules of PowerShell. Nothing that says you can't define your hash table as a variable. So if you right-click and choose go to definition. So that's the same thing. So you'll see there test spec check. So on my test where it shows the test in brackets, it's pulling it from the test there. So that's where the module string name, AZ accounts, module specification, minimum version, maximum version, that's where it just pulls from that.
And we don't have it in a before each and before all or anything right here.
No. It's in the context, so because it happens at discovery, that's why it's not in a before all, because I need it to be available during discovery to be able to generate the tests.
But why don't you just have it before discovery?
Well, where the
You could use a before discovery block instead.
Oh, I'm sorry, I apologize. So yeah, you could put in a before discovery block to be very explicit, but that actually happens like in discovery. But like you could put in a before discovery, but I don't need it to be there before discovery, so that's like just unnecessary ceremony.
So if it's in a context but it's not in, say, a before each or anything like that, it's treated as during discovery?
Correct.
Okay.
So like if you wanted to read from a file and generate your test based, or if you want to read from a directory and generate your test based on the files that are in that directory, you can do that. You just have to do that during discovery, because once you hit runtime, you can't change the test definitions. Well, you can, but don't do that. Like everything else, like there's always a way around anything in computing. But okay, does that answer your question about the data-driven tests? Ish, sort of. Okay. All right. So like that's kind of the core things about Pester. And all of this works like whether you do it in code spaces, anywhere you can run PowerShell, you can do those operations. So I think, let's see, where are we at?
We are at 4:42.
Great. So I think what we could do is, first of all, I guess, are there any open questions? I guess we can go switch to Q&A time for a bit. And then we had an idea we were going to try. I don't think we'll have time, but we could maybe do like one test maybe that we could try. So are there any questions? It's like just general questions so far. There's a lot, especially if you've never seen Pester. Yeah?
How long does it take to install the VMware PowerShell, the module class?
Oh, you want? Okay, do we need to revise it and turn this into the Pester module fast happy hour? Like, because, okay. As an aside, all right, so as an aside, let's find out. We could do it on again, this is going to be very Wi-Fi specific unless I go into a code space or something. Let's see. IMF. And IMF is just an alias for PowerCLI, or for module. What if? It's VMware, not PowerCLI, excuse me. Yeah. So just rolling on modules there. And this is happening over just conference Wi-Fi right now. So the first time it'll do it, there's cold hits to the PowerShell gallery. It's probably lagging on one here. Like, what's 522? Did not like that. It did. It's really good at it. Let's try a new one. Let's try a new one. I do know, like, I don't have, okay, there we go. So that time it happened a lot faster because, so what you're not seeing here is there's a Cloudflare worker that caches all this information from the PowerShell, because the PowerShell gallery has a lot of slowness in it, and I have a thing in front of it that speeds up a lot of the slowness. So I didn't answer your question, because I don't have my normal prompt that automatically does this part. But so this is just to get the tree. So to get the tree, when it's warmed up, is 400 milliseconds. So let's try actually installing these, and you can see what that looks like. And if you do the what if, you get this really nice view of what's going to be installed, what module version it's going to be, and it does all the dependency resolution in that and where it's coming from. And this works not just with PowerShell Guide, it works with any NuGet version 3 repository. So if you have your own GitHub packages, if you have an on-premise one, you can register those and use them with Module Fast. So let's do the actual install. We'll do, I'll take off the verbose to let it do its, so there it's going to resolve the dependencies. And this is probably going to be pretty slow because it's got to download them. But the process, I'm doing this over conference Wi-Fi, so this isn't going to be as impressive as if you were like local, because this is purely limited by the bandwidth of downloading these modules. It's not doing them individually, it's downloading them in parallel, but it's whatever the speed of my Wi-Fi was. If I was doing this on like a gigabit connection, this would probably already be done. Oh, there it goes, it's starting to pick up. Because I had to wait for those modules to get downloaded. And it's decompressing on the fly, putting them into my module folder. Now we're waiting on a few more that are probably a little bit bigger. But already slightly faster than install PS resource, right? And now we're just gonna have a couple laggards. And by the way, this is another one of those, like if you turn on debug, you will see the entire process of what's happening. But otherwise, you typically don't want that level.
Does Module Fast work with private repositories?
Yes, as long as they're NuGet version 3. It doesn't work with NuGet version 2. And it doesn't do like file shares and stuff, because there's nothing to improve there. Like, install module works just fine for those.
We had another question over there.
Yeah.
Just at a high level, what are you testing in your repository? Like, just parameters and functions?
Good question. So what am I? So in this repository, and like I can show like one for KeyPass. Like what do I test for KeyPass? The question is like, what am I choosing to test in my repository? So for this project, there's a few things I want to test. So one thing is testing this ginormous, disgusting class called Module Fast Spec. That's one thing that I really wanted to test because there was a lot of stuff in here that I just need to make sure is correct. Because one of the really tricky things about modules in this case is you're adapting between the old version format, which is 1.2.3.4, and there's 4 octets, and semantic versioning, which is 1.2.3 dash or plus. And the way that those convert, there's so many edge cases in making sure, like if something has a NuGet version assigned to it, how do you specify that as the correct PowerShell modules folder in the old version format? How do you keep all that straight? And more importantly, how do you compare the differences? How do you compare an old version 3.2.1.0 to a semantic 3.2.1-alpha 1? And how you convert 3.2.1.1 to -alpha1, which one's supposed to be ahead, which one's not. There's no rules for that. And so I wrote, the script used to be about 1,000 lines longer to do all that stuff, and then I just gave up and imported the NuGet versioning module and let them handle it. But, so this used to have a lot more tests around that stuff. But so now basically I'm just testing that that class works as expected. I test that when I bring something in, like this dash in here. So like here I am I'm taking a module specification, which this I can just run. This is a standard, if you're not familiar with how regular PowerShell module, this is built-in PowerShell stuff. So a module specification, this is not gonna work because I don't have the namespace. Yeah, I can probably auto-complete it with a tab here. Yeah, there we go. So when you do like, get module, list available, you get a bunch of modules. If you put this into get member, you'll see there of this type, oh, not a grouping, that's cheating. Is that still gonna be your grouping? It is still gonna be a grouping, fine. This might be a thing that's, so let me do this a different way. Help install module. So when you do an install module, you have this option to specify an input object that's this special module specification format. And so one thing I want you to do is I want you to be able to do like GMO thread job, pipe it into install module fast. And apparently I didn't set that up right, so bad example. But yeah, if you have module specifications, this is testing that like if you're given a module specification that it converts to a module spec without having to do anything special. Like you don't have to use a convert to this thing. Like it just casts correctly and then all the stuff there works. Then as far as actual operations, with get module fast plan, I'm testing that all the parameter stuff works. So this is like if you give it a name that it works. If you give it a module specification, if you get a module specification with the required version, if you get a module specification with a maximum version. If you give it with all those little string shorthands, like all the permutations of things you could do to specify those work. So like if I want, install Pester with an exclamation mark. No, that's why it didn't work, because I don't even have it loaded. So I need to update because it's already satisfied. So this, with the exclamation mark, it'll find the pre-release version rather than just the regular one. It's like little syntax things like that are added. And so, and I'm testing for certain combinations of parameters where if you provide like both module specs and strings, like I wanted to account for all these cases because I like my commands to be very PowerShell-y. I like there to be so many different ways to do them. They're like, if you have a preferred way of doing things, if you want to pipe things to it, it should just work. Like it should either figure it out or give you an error that that's not a valid type of object. But if it's an object that should work, I like to have that. Like if it's acceptable on the command line, I want it to be able to be pipelinable and that kind of a thing. And then there's a lot of stuff of like testing that when I fetch information from the gallery, that information is correct. And this is also kind of sort of tests my little NuGet v3 to version 2 bridge, but there's separate tests for that. And there's like all these casts, and then the actual install process. Like when you install a module, if you install scope, this is an example, a great example of, this was a feature request. By default, module fast doesn't install modules to your documents folder because we all know now OneDrive screws with that and we all hate it. So module fast by default actually installs it to your local app data and transparently sets it up so that your PS module path includes it, so that those modules don't get synced by OneDrive or anything like that. And that's the default path on Linux, and I just now also do that on Windows. But somebody wanted to say, I want module fast to sometimes put it in that documents folder. And I'm used to doing install module -scope current user. Could we just have install module fast -scope current user? So sure, great. So I got that feature request. I checked it out, started a new feature branch. So I just had a new Git branch that was like for that feature. And then the first thing I wrote was like my test. I was like, okay, if that destination works, I want to make sure that when I install it and I can resolve path, that path works. And I put error action stop there to say like, throw an error if this test doesn't work, so I'll know it'll fail. And this one has this is an example where like an after all you could use, but I just did a try finally where we try to do it. We install the thing, we resolve it, and regardless of if this fails or not, it then goes through and removes that old module, putting it back to a pristine environment. And this I kind of had to do here because no matter where this runs, you can't really like mock documents. Like I have to test on the system that it is. So I just want to make sure that doesn't sit around and maybe break something else I was working on for whatever I was testing. And so I defined these tests, and then I actually implemented it. So I defined these tests, ran it, the tests failed. And then I implemented it and kept implementing and fixing it until the test passed. And then once that was done, it looked good, made that a pull request. The tests go up to the pull request, GitHub Actions, ran all my tests again, only it did like the big full suite of them. And once everything passes, then that's ready to merge. I merge, close the issue. This has been implemented, try it out, you know, and if not, let me know.
I'm noticing that you don't have an assertion set in these tests right here.
The insertions?
Assertion isn't a should.
Oh, assertions, yes. So the question was like, I'm not using should, for example. And the reason simply being is in some of these test cases, I don't need the extra information that should has. I just know this test either works or it doesn't. And so in this case, remember the first test that I wrote was just an empty script block and it passed? And then once I put an exception in there, it failed? That's a perfectly valid test. You don't have to use should. You'll get less information, but I'll know when this throws, I'll get the throw and I'll get the exception information and the exception information in my code for where it threw, so that I can quickly go to that and get it. So you don't always have to use should, and a lot of times I'll use should if I'm validating data, like I don't know if I search should. See, I use should 151 times in here, but this is an example of a test where it just didn't make sense. I just didn't need it, or I just was just doing it fast.
It's also similar when you have an if-else statement. In if, it also doesn't have to resolve to true, just something that converts to true.
Yeah. Any other questions?
When you have an error through that's not within a should, will it skip all the remaining tests in that it, or all the remaining its?
So if you throw a naked it will fail that test, but the process will continue. Unless you in Pester, one of the options in that Pester configuration is you can set it to fail early. So like if any test fails, stop. Don't do any more tests if any one test fails. And there's reasons you want to do that if you're doing local development, but I generally don't do that for like my CI/CD pipeline, because like if a test fails, I want to know every test that failed so that I can fix that one and then resolve the others, because I don't want to like go through, fix that, and then find out there's another one, and play whack-a-mole and wait for my CI/CD to run 15 minutes every single time. Like if it's going to fail, I want to know every test that's going to fail so I can try to fix it all at once. Does that make sense?
Yeah, so the example you had previously where you were casting the module spec to your
Yeah.
that wasn't within any kind of a sheet. So presumably if that were to fail, if the cast were to fail, then what would happen to the remaining lines in the
It would move on to the next data-driven test and just say that test failed and move on to the next one.
Take the remaining lines in that it.
It would, yes. For a data-driven test, and again, don't quote me on this, I'm going to get Cunninghammed on this, I just know it. But as of the last time I did, as I recall, we could test it. We got time. We got 5 minutes. Let's go back to our mocks here. Should I make Jaap write it? All right, describe data-driven.
I mean, even in a regular test, even if it's not data-driven, just if you have a single it and it has, say, 5 statements, and the first one.
Yeah, so like let's say you have like multiple shoulds in a single it. So yeah, if one of those throws, then it stops at that point. It doesn't evaluate the rest of the shoulds.
Okay, but if
Unless it's wrapped in the like should throw script block thingy.
but it's a data-driven test, then it will be like a continuum for each. It will skip the remainder of this data-driven.
Yeah, so again, the question is like, when you have terminating errors, like at what point will it stop a test and move on versus like not stop a test? And basically the short is basically whatever's in this, whatever's in here will stop and then it will move on. Because Pester just executes that as a script block. The guts of Pester wraps everything you do in a try catch. So when it runs that one, if that script fails, then that script's gonna throw a terminating error, go up to that little internal special Pester wrapper. It has a try catch and it'll take that as like, okay, this test failed. If you should throw, it'll do a bunch of extra stuff to gather information to give you a nice error message. Otherwise, it's just gonna take the default error and then it's gonna move on and run the next test.
So a should not throw as an assertion is effectively kind of redundant. What does should not throw?
What should not throw gets you is that, one thing that what should not throw does is should not throw plus a message is a way to make sure it doesn't throw a very specific error message.
Generic should not throw is the same.
Yeah.
As leaving nothing and allowing the error to be thrown naturally.
Pretty much. You'll get a little more information, but otherwise, like, I personally never use should not throw. I use should throw, or I just, like, if it throws, that fails the test, and I get the information. Yeah. I mean, it just depends on whether you need the extra information or not. My typical pattern is I will use should throw all the time, but I never use should not throw. I just if it throws, it fails the test. If I'm expecting it not to throw a test, or expecting it not to throw an exception, then if it doesn't throw, then I don't worry about it.
Well, that's easier. I've had to wrap
Yeah.
Syntactic. So to just have the command stand without
Yeah.
any insertion would be neat.
Yeah, so again, to summarize, like if you have a test and you're just testing that the command works, if it throws and you haven't already handled it in your command, or you don't have a test case where you're planning for that to fail, like if you're testing for a case of it not, like you're testing for a case if something exists or doesn't exist. If something else happens in that throws an error, any of your should throws should match for that very specific error failure you're looking for. And if you're not even using that at all, it's my recommendation that if you're testing, you just test the command, and if it throws an error, that should just be a test failure. But you don't have to wrap every single command in should not throw. I think that's redundant. I don't think it's worth doing.
It's like a non-terminating error when you do error action stop.
And it becomes a
Yeah.
In the Pester config, can't you set should error action continue if you wanted to?
Yeah, so in the Pester configuration, you can modify it so that like if an error happens, you can have it to continue. That doesn't count for like the script block. Like if that block throws, it's not going to keep going down to the next shoulds. Like if I have this should be that way. I don't want to couple. Like if it, right here it throws, it's not going to run the rest of this block, but it can move on to do the other ones. Because, again, Neo, Matrix, behaves with the rules of PowerShell. Whenever you have a script block, if something throws a terminating error in a script block, it stops right there. There are some things you can customize for non-terminating errors. Like if it does a write error, you can basically, like the wrapper that's around there's a setting in there to say, does a write error basically automatically get error action stop on it or not? You know, like it's like setting error action preference in a way, if that makes sense. Like it's like the equivalent of setting error action preference stop versus error action preference continue. So if you have a script where you want like write errors to show out and you don't want to do any kind of, or you want to capture it to a variable, that kind of thing, and you don't want that to force a terminating error, then you know there are ways to make it so that that kind of a test works. If you have a process like a non-terminate where you want the thing to like report 15 errors as opposed to terminate on the first error. Like maybe it's a batch process where you're having it be resilient and skip certain records but not throw on the first problem it comes across. Like you can write tests in such a way that you can handle those non-terminating errors without it like stopping the whole script, if that makes sense. All right, well, we are at time, so thank you very much. I didn't even get the good questions right up. Feedback. So again, thank you, everybody. And if you have feedback, let me get the QR code up here. If you want to submit and say you wish we talked more about Module Fast, feel free. But yeah, so again, thank you very much. Appreciate it, and have a good day.